quantify that. So in order to quantify the degree of the security of the substitution box against the differential attack, Kasha and Ivor, she introduced the notion of what is known as differential uniformity. So I'm going to define differential uniformity in the next slide. So first, suppose you are given a map from finite field FQ to FQ, and A is any element of FQ. Then the derivative of F in the direction of A is denoted by dfxa, and this is how you define dfxa is nothing but f of x plus a minus fx. Some people call it difference map. I mean, in general, crypto community call it derivative map, and math community usually, they call it difference map. So this is how you define the difference map. You have a function from F2 to F2, and now what is the differential uniformity basically? So for any A, B in the finite field FQ, the difference distribution table entry. So you can make a table, on one hand you have A's, on the other hand you have B's. So you take A and B, then you can make a difference distribution table, and its entry at the point A comma B is denoted by big delta F A comma B, and it is denoted by the number of solutions of the difference equation. So this is how you define the difference equation. You look for the solutions x in FQ such that df x comma a equal to b, or in other words, f of x plus a minus fx equal to b. So you count those solutions, and after counting that solution, whatever the number you get, that we define the entry corresponding to the point A and B. So basically, there is one column that represents A and one row that represents B. So you want to find out, it's like matrix, you can form a table where if you take A and B, then what is going to be the entry of that table? The table is normally known as, by crypto community, as difference distribution table. So in short, DDT. Now, what is differential uniformity? So if you take A to be non-zero, then there is some noise. Maybe you can mute the participant. Yeah. So the differential uniformity of F denoted by delta F, and this is nothing but the maximum number of solutions, delta F AB, where AB in FQ and A is non-zero. So the maximum number of solutions of the differential equation is known as differential uniformity. So the lesser differential uniformity you have, your function is going to be stronger. Yeah, it can avoid the differential attack. So it's another research problem that people are trying to construct functions where low differential uniformity. So most often, in practical scenario, we deal with the functions over field having characteristic 2. So in that event, people are trying to construct function with differential uniformity 4, differential uniformity 6, and so on. So that's another direction of research actually. So now we make some more definitions. Okay, why it is not moving? Yeah, it is moving. So if the differential uniformity you denote by little delta, then we say that the function is delta uniform. And if delta is 1, we say that the function is perfect nonlinear function. And it's also known as planar function by mathematicians. I mean, cryptographers, basically they call it perfect nonlinear function, and mathematicians, they call it planar function. And then we have what is known as almost perfect nonlinear functions. So if the maximum number of solutions of the differential equation is 2, we call it APN functions. And it's an interesting research problem to construct functions or to design functions with low differential uniformity. of course, when you are dealing with the finite field having characteristic 2, you will never get differential uniformity to be 1, because in that event, if you look at this equation, if x is the solution of d of x a comma b, then x plus a is also going to be the solution. So the solutions will occur in pair. So that you will never get planar function. Planar function you can get only in prime characteristic, not in over even characteristic. So anyway, so now there is a generalization of this difference function. So in the year 2002, Borisov introduced the notion of multiplicative differentials of the form fcx comma fx, and used this new type of differential to attack some existing ciphers. So motivated by this, in the year 2022, Ellingson et al., they defined a new multiplicative differential in the following way. So this paper appeared in IEEE Transactions on Information Theory in 2022, and it has been picked up by the community, and several follow-up papers, I think more than 20 papers have been written since 2022. So this is how they generalized. So you have a function again from fq to fq. A and c are the elements of the finite field. So now you take this difference map, fx plus a minus c times fx. So you remember earlier definition of difference map, c was 1. So here I'm taking c to be an arbitrary element of the finite field. So if you define the difference map like this, then you can define the notions of differential uniformity, new notions of differential uniformity, and so on. So this is how you define C difference distribution table now. So number of solutions of this difference equations. So, and similarly, you can define what is called C differential uniformity. So C differential uniformity is nothing but the maximum number of solutions of the difference equations, are the biggest entry in the C difference distribution table, where AB are in FQ. And in order to make this definition aligned with the classical definition, whenever A is not equal to, we take A equal to 0 whenever C equal to 1. So in this definition, whenever C equal to 1, we take A equal to non-zero, so that our classical definition of differential uniformity and the new differential uniformity, they match. So this is how we define the notion of C differential uniformity. And again, we can define some new definition, like if the C differential uniformity denoted by little delta, we say that the function is C delta uniform. And if the C differential uniformity is 1, then we call it the function to be perfect C nonlinear function. And if it is 2, we call the function to be almost perfect C nonlinear function. Again, there are another direction of research where you can try to construct function with low C differential uniformity. So now, what we have done in our paper, so we have taken some standard permutation polynomials, and we have tried to compute C differential uniformity. And also there is a notion called boomerang uniformity that I'm going to introduce later of those functions. So now let me come to what are the permutation functions that we have considered. So in 2022, Verlet and Leander, they proved that this function, x plus trace of alpha x plus x to the power 2k plus 1, this is an involution over finite field f2m. So I mean, this is an involution when n is greater than or equal to 3 and odd, if and only if this happens. Okay. So involution means it's a permutation function, and it's a self-inverse. So G inverse is G itself. So that is what was proved by Leander in 2022. So it's a permutation function. Now, not only they proved this, but they have also used this function gx to construct a differentially 4 uniform function, gx to the power L, where L is given by this. It's the inverse of 2 to the power k plus 1 modulo 2 to the power n minus 1. And differentially 4 uniform function are very, very useful when it comes to cryptography. And it's interesting problem. Constructing functions with differential uniformity 4. I mean, if you construct with differential uniformity 2, that's basically you are constructing APN functions. That's quite challenging actually. So the next best you can do is construct functions with the differential uniformity 4 over the boundary field. So they first proved that this function is involution under these conditions, and then they used this function to construct differentially 4 uniform functions. So now what we have done is basically we considered the C differential uniformity of this involution Gx and showed that the C differential uniformity of this involution is 2 for all C other than 0 and 1. And we also computed the CDDT entries explicitly. So we have, taken up this function and we have completely computed the C differential uniformity of this function. And it turns out the C differential uniformity is 2 if you take C to be neither 0 and nor 1. So it's quite an interesting result. Now, so this is what the result is basically. So the following theorem gives the CDU of the involution Gx for all C in FQ other than 0 and 1. So this is what the result is. These are the CDT entries. So where A is basically trace of this quantity, B is trace of this quantity. So this theorem basically depends on what is A and what are B. If A is 0, then the CDT entry is 1. If it is A is 1, B is 0, then it is 2. If A is 1, B is 1, then it is 0. So I think I'll skip the idea of the proof. I'll just tell you. So we have actually used what is called Weyl sum and various properties of the trace function in order to prove that. So basically, if you look at this is the equation, we have to find out the number of solutions of this equation. Gx plus A plus CGx equal to B. And then use the definition of C, then you arrive at this. And then this complete equation can be further written in this form. And the number of solutions, here we have used the Weyl sum that I described earlier. The number of solutions are given by this. And then you compute this sum somehow by using various finite field properties and trace properties and so on. So that was the idea of the proof. And we also remarked that if you take n to be bigger than or equal to 3, which is odd, and alpha with trace equal to 1, then for C equal to 0, the function, this turns out to be a PCN function, perfect C nonlinear function. And for C equal to 1 case, so C equal to 1 case must give you the differential uniformity, the classical differential uniformity. So we have computed that as well. And it turns out the differential uniformity is given by these expressions for the involution Gh. Now, another permutation polynomial that we have considered is that was discussed by Charpin and Keoregan in the year 2009, and they showed that this function f1x given by x plus trace of 1 over x square plus x is a permutation of f to the power n. They have proved that. And this paper of Charpin appeared in Finite Fields and Applications. Later, Tan showed that when n is even, the permutation, you compose this function with the inverse function, x inverse. Then you basically get this. So this function turns out to be differentially 4 uniform. As I told you, constructing differentially 4 uniform function is very, very interesting problem. And if you can do so, it will get published in decent journals like Finite Fields and Applications, Design Codes and Cryptography and Communications, and so on. These are somewhat they publish this kind of results. These are decent journals. So now we sort of extended the result of Tan et al. And gave bounds for the CDU of Hx for all C in FQ. So CDU means C differential uniformity, and here is the theorem actually. So so C differential uniformity of this function is given by if C is 0, then it turns out this function is basically PCN. So that means there is only one solution of the difference equation. And if trace of C equal to 1 is same as trace of 1 over C, then this is bounded above by 8. And in all other cases, it is bounded above by 9. So now coming to another concept called boomerang uniformity. So this notion was introduced by Wagner in the year 1999. And he introduced a new kind of attack that is known as boomerang attack. So the name is justified because if you really look at, go to some Wagner's original paper, then you will realize the name boomerang is justified. I'll not go into details of those. So it's basically generalization of differential attack. So if you understand differential attack well, then you would also understand boomerang attack. So it's a sort of generalization. And in the year 2018, like we have differential uniformity and difference distribution table, these notions were introduced by I forgot Anna Catney. So she introduced the notion of boomerang uniformity and boomerang connectivity table. So difference distribution table, which in short is known as DDT, boomerang connectivity table is BCT. So now what is boomerang uniformity? So it's basically to quantify the resistance of a function against boomerang attack. And Baura and Catnew introduced the notion of boomerang uniformity. And for effectively computing the entries in the BCT means boomerang connectivity table, Lee et al., they proposed an equivalent formulation as follows. So this is the formulation by Lee et al. So for any A, B in FQ, the BCT entry of the function f at the point AB is denoted by BFAB, and it is nothing but the number of the system of two equations, fx minus fy equal to b, fx plus a minus fy plus a equal to b. So if you look at the common solutions of this system of equations at the point a comma b, then that is known as BCT entry at the point a comma b. And then we have similar notion of boomerang uniformity. So the boomerang uniformity we denote by in short by BU. So boomerang uniformity of the function f denoted by BF is nothing but the maximum entry in that table. So the maximum of BFAB, where AB in FQ star. And what we have done is basically we have computed the boomerang, the entries of the boomerang connectivity table of the function gx. You remember gx I introduced earlier, it's an involution. And also, I think, let me look at the time. Yeah, still we have some time, 5-10 minutes. So similarly, we have also proved that if you take this function hx, then it turns out that its boomerang uniformity is bounded above by 12. That's also quite interesting result. And here are, so I'm just concluding my talk. So basically, if you look at from the beginning, that we have initially taken the function g. So we have computed its differential C differential uniformity. And then another function that we have taken is basically this function hx, which is the composition of this function with the inverse function. So the differential uniformity was already computed by Tan et al., but we have extended and computed the C differential uniformity. But this function, we have not done anything about this function f1h. We have computed the C differential uniformity of this function and also the boomerang uniformity of this function, but this function we have not touched. So it is quite interesting problem to look at what is the C differential uniformity of the original function and what is the boomerang uniformity. That we have not done yet. And it is not that we have not tried, but somehow the computations are quite complicated, and we have not been able to succeed. But it is interesting research problem. Similarly, here if you look at the function gx, so we have computed the C differential uniformity of this function. But what about gx to the power L, this function? This is a differentially four uniform function. So it's basically composition of gx with x to the power L, where L is given by this. So what about this function? Can we compute the C differential uniformity of this function or not? This is again an interesting problem. So there are two functions. So total, we are dealing with four functions, gx and gx to the power L, f1x and hx. So we have only considered two functions so far in our paper, but two functions are still there, whose differential uniformity and C differential uniformity and boomerang uniformity are yet to be studied. So these are two open problems, and that we have sort of mentioned in our paper also, these as open problems. And not only that, there is a generalized notion of C boomerang uniformity. So in fact, one can also study the C boomerang uniformity of these permutation polynomials. So now, in order, in order to conclude the paper, I will just list out few of the problems that I already told you. So we have computed the CDU and BU of two classes of permutation polynomials, namely GX and HX. But it remains open to compute CDU and BU of GX to the power L, where L is given by this, and the original function f1x. So that's quite interesting problem. Other interesting problem could be to construct polynomials over finite fields with low C differential uniformity. I mean, low could be 4, 6, 8, 10, 12, but it is an interesting problem. Now, this is even more interesting problem to find the necessary and sufficient conditions for the power map x to the power d to be PCM over the finite field of odd characteristics. And particularly what happens when C equal to -1. So this is again an open problem, and we do not know anything about even as simple map as just a monomial power map x to the power d. When we can say that this is going to be PCM. More interesting problem could be, what about the binomials? What about the trinomials or pentanomials? So we have not even understood behavior of a monomial as far as the notion of perfect C nonlinearity is concerned. So these are some interesting problems, and also compute permutation to construct permutation polynomials over finite field of even characteristic having boomerang uniformity 4. It should be construct, not compute. So this is again an interesting problem. So I have listed several interesting problems that are not only interesting in view of mathematics, but also are interesting in view of cryptography applications. So with this, I think I would like to conclude my talk. I mean, 10 minutes before the allotted time, and I really thank the organizers for giving me the opportunity to be part of this wonderful conference. Thank you very much.
Thank you, sir, for your knowledgeable session. Hope like all the participants along with us could add on so much to their knowledge database. So thank you so much for your benign presence.
Thank you.
Dr. Sartaj, hello.
Hello.
Yeah, am I audible? Kya haal hai?
Yes, you are audible. Sorry, my video doesn't work today. I don't know. Maybe I might have done something with the setting of this Zoom. I was trying to, enable my video. It is not somehow I'm not able to do that.
No worries, sir. Like your words were all intact, like towards us. So like we were able to get whatever we wanted to. So thank you for that.
Thank you.
So, Varun sir, will you confirm, like, are we okay, like, to start with the technical session?
Technical session will start sharp at 11.
All right.
So we need to wait for 10 minutes.
Okay,
So
sure.
if
So
if
like
there are
participants, like if you have any question to ask, to the keynote speaker, like you can put forward your questions. You can either write your question in the inbox, like Varun sir will read those questions for you, or like you can unmute yourself or ask that. Raise your hands if you have any questions. I will like allow you to unmute yourself, and then like you can ask the question. Participants are advised to ask questions on the talk. So if we have anyone in the crowd, in the audience, like if you have any doubt, any query about all these, like I like just love the method of boomerang uniformity. So like the word was already known to you. If you have anything to ask, you can do that now. So
Hello.
yes. Hello.
yes, Atul sir, you are audible. Please go on.
Hello.
Yes, sir, you are audible.
Hello. Yeah, Dr. Sartaj.
Yes, yes.
अरे भाई मैं बात करना चाह रहा था बट हम लोग तालमेल नहीं बैठ पा रहा है. Now am I audible?
Yes,
आवाज आ
yes.
रही है?
Yes, perfectly audible. Yes.
Oh. Land mode. Okay. This cryptology and network security will.
Sir, not audible.
So Varun sir, if you have anything to ask, I mean, like we can make use of this time by interacting with Professor Sartaj or Hassan. So
Yeah.
And no problem.
Once again, I ask to all the participants if anyone wants to ask anything. Otherwise, the next session will be started sharp at 11 or 11 to 11:03. So we have 5-6 odd minutes to wait. All the participants can note down the email ID of Sartaj sir. If you have any query, maybe later on, so you could write a mail to him also. I hope all of you have noted down the email IDs that I have already shared. So if you have any query or maybe you are interested in the same topic, you could write email to sir. So, all right, I think this session is ended now.
right.
And next session, which is the technical paper presentation, session 2, will begin sharp at 11.
So Sartaj sir, like we request you like to stay for the next session as well if you have enough time. It's like choice is all yours. You can like get occupied with your daily work.
Okay. Thank you. Thank you so much, Garima ma'am.
Thank you.
Thank you, sir. Thank you.
So So before we leave, like participants, now we don't have any outsider with us. Like I want you people to come up with the questions and queries when you listen to the talks. Like you can always like get some questions. You can already prepare a few questions so that like you ask to them. This is how like you interact with like these erudites, right? We don't meet such people so often. So if you ask questions, that is like the best thing for the speaker as well and for you people as well to understand the applications of all these to our daily life. So do ask questions, right? Be vocal, express, and learn something to ask, right? So next talk would be like from again a very erudite person, and I want you people to like prepare some nice questions wherein like you can ask something. So like otherwise like your coordinators are taking care of this, right? You know the name of the topic of the conference. So mostly like around like 20 students I want to ask question in the next talk, right? So prepare a well like drafted question beforehand, even now, even before listening to the talk, right? You just like prepare some questions on the basis of computational mathematics, mathematical applications and all, and then like I will call upon names, the ones like who will be asking the questions, right? So do that now. So Varun sir,
Sham sir is there?
okay.
Sham sir?
Sham sir he has not joined yet.
He has joined. I could see him, but I need to ask him to unmute.
Yes, yes, he's there now.
Sham sir, am I audible to you?
Yes.
Sir, there is one information. One participant have just informed me, paper ID 31, Neelam Bansal, that she is in the hospital, so she might not be able to present the paper. Maybe on her behalf, somebody else will present.
The second author is Mala Tandon.
Neelam Bansal, yes, we can see in the program schedule. So might be she is appointing a proxy on her behalf. Paper ID 31. Yes,
31.
Neelam Bansal and Mala Tandon. So maybe she is appointing Rajat sir.
Okay.
Okay, so you could allow. She got some fractures, so she's in the hospital, not be able to present. So maybe she has appointed a proxy.
I will ask the authors of having ID 31.
Yes. When somebody will come with ID 31, then you may query.
Rajat will present the paper.
Yeah.
Okay.
The session starts with paper ID 13. Arpit.
Yes. It will be started at with paper ID 13. Okay.
13. I have just talked to Lalit sir also. He will be joining within couple of minutes.
Okay. So when we should start it?
Somewhere around 11:05.
11:05. Okay.
Paper ID 13 is there.
अब उसको देखिए मतलब कोई भी उसको जैसे लिखा जैसे वो बोले ठाकुर जी की बेटा है
Varun sir,
अच्छा
ठीक है.
like Lalit Garg sir has joined. So are we
Yes, yes.
supposed to start?
We need 2-3 minutes more. There is some
Sure.
technical
Sure.
problem going on in the background, so we
Sure,
need
sure.
to.
All right.
है ना
Garima ma'am? Garima ma'am?
Yes, sir, I'm right here.
Yes, yes. You could start the session. Paper ID 68 and 70 will proceed first.
All right. So
Because of some...
hope like Shyam sir has made a note of this, right?
Yes,
Yes.
yes.
All right.
So let us start the session.
So
Paper ID 68, Sanjay Sahu.
Lalit sir, good
Sir,
morning.
Sir, Shyam sir, let me introduce the session chair with you and participant. Then like we can start with this session, right?
Sure.
So I wish good morning to everyone listening to me. I, Dr. Garima Williams, again on behalf of PSIT organizing team and technical sponsors ISTE and IEEE chapters, welcome you all to the International Conference on Computational Mathematics and Engineering Applications. Now is the time to move ahead with the first technical session of the day. So all the participants kindly be informed to be here as your technical session will take place now. So wishing you all the most and more from this conference. This session will be chaired by Dr. Lalit Garg sir, Senior Lecturer, Computer Information Systems, University of Malta. Dr. Lalit Garg is an information technology innovator, academician, learner, teacher, developer, keynote speaker, consultant, and researcher with a demonstrated history of working in the higher education industry and an excellent research publication record. Presently, he is a senior lecturer in computer information systems at the University of Malta. He is also an honorary lecturer at the University of Liverpool, UK. He has also worked as a researcher at the Nanyang Technological University, Singapore, and the University of Ulster, UK. He has supervised more than 180 master's dissertations and guiding 4 PhD theses and shaping the future of many other students. He has published over 90 technical papers in referred high impact journals, then conferences and books, and has more than 590 citation count to her publications. And some of his articles awarded Best Paper Awards. He has delivered more than 20 keynote speeches in different countries, organized, chaired, co-chaired 16 international conferences, and contributed a technical committee member or a reviewer of several high-impact journals and reputed references. He is awarded research studentship in healthcare modeling to carry out his PhD research studies in the Faculty of Computing and Engineering at the University of Ulster. His research interest lies in participants are advised to make most of it so that you can ask relevant questions to him. Modeling and simulation, information systems, operational research, and forecasting, health and social care modeling and missing data analysis, biomedical computing, neuroimaging, metabolomics, and personalized medicine, knowledge discovery and data mining, e-learning, human-computer interaction, cloud computing, and pervasive computing, blockchain and its applications in healthcare. So join me in welcoming Professor Lalit Garg sir, and I would request Professor Shyam Sundar sir, PSIT, to accompany him in chairing this session. So over to you, sir.
Okay, sure, madam. So let us begin the session. Paper ID 13, Arpit Mishra. Paper ID 13, Arpit Mishra. Paper ID 19, Nikhil Chaturvedi.
Sir, paper ID 13 and 19 are rescheduled because of some problem at their end.
Okay.
So you could start with the presentation, those who are present.
Paper about paper ID 33, Prem Kumar Karan. He is also not present. Paper ID 41, Vakil Kumar. Paper ID 68, Sanjay.
Yes, sir.
Sahu.
Yes, sir.
So please start your presentation.
Thank you, sir.
Okay.
Now my screen is visible, sir.
नहीं हो रहा है.
Yeah, visible, properly visible.
Okay. Thank you, sir. Good morning, everyone present over here. So, myself, Sanjay Kumar, sir, and I am going to present my research work with title Robust Higher Order Numerical Scheme for Time-Dependent Singular Product Differential Difference Convection Diffusion Equation. I have done this work with my guide, Dr. Vikas Gupta. These are my outlines. Now, so in this step, I consider the problem is a time-dependent singular product problem with containing a delay parameter in the time direction. So, and the equation is this ut minus epsilon uxx plus a of xt ux plus b of xt u is equal to minus c into u of xt minus tau plus f of xt. Here, in the right hand side, in the source term, there is a delay parameter that is tau here, which is greater than 0. And this differential equation is defined on the domain 0 to 1 and 0 to t. Here, the initial conditions is given, including the delay space also. So u of xt is equal to gamma b of xt, where gamma b, capital gamma b is equal to 0 to 1 times minus tau to 0, where tau is a delay parameter which is positive, and with two boundary conditions. Here gamma lt defined at x is equal to 0, and gamma rt defined at x is equal to 1. And in this, here I am taking some conditions here where convection coefficient A greater than equal to alpha greater than 0, and reaction coefficient B also greater than equal to beta greater than 0, and source term C of xt greater than equal to 0. Under these assumptions, the solution to this problem class have a boundary layer, parabolic boundary layer near the right lateral surface, that is at x is equal to 1. Which will be, I'll show you in the example section how it will come. Here, this type of problems occur in many branches, such as biological and chemical or physical systems, which are characterized by both spatial and temporal variables and exhibit various spatio-temporal patterns. If you take any example, if we can find this type of problem in population ecology, generic regressions, and also in modeling size, time dependence cells, cell division, and cell growth also. This type of problems we can find there. And also, if I can take a typical example here, which is an example where I have taken here in the control system, ut minus epsilon ux plus b minus b of g of u of x t minus tau ex, which is equal to c f of u of x t minus tau and minus u of x t. That is, here u is the temperature distribution of the metal sheets, and v is the velocity, and f, both f and v are dynamically adapted controlling devices monitoring the current temperature diffusion. And however, we are taking here tau is the delay parameter here. And in this problem class, there are some previous related work I will present here. That means in one, Ansari et al. Constructed a standard finite difference operator to solve the reaction diffusion problem, which is almost first order operation in both space and time. Then Kumar and Kumar also developed a hybrid numerical method, or a domain decomposition method for singular reaction diffusion problems with a delay in time. And Kumar and Kumari also give Crank-Nicholson finite difference scheme and a midpoint oppoint scheme, where he used Crank-Nicholson scheme in the time direction and midpoint oppoint scheme in the space direction, which is in both. They saw that in time direction they are getting second order accurate and almost first order accurate in space direction. Odile also constructed a new finite difference scheme, stable finite difference scheme, and Aditya et al. Also constructed a uniformly numerical scheme by using standard finite difference operators. And Claver et al. Also get Hoodie differential equations, Hoodie difference scheme. Hoodie stands for higher order difference approximation with identity expansions and for convection diffusion problems. So in this problem, also I am going to I discretized the space domain using implicit Euler scheme, and the the time domain I am using the implicit Euler scheme, and the space domain is discretized by using Hoodie difference scheme. So these are some maximum principle. That means it will give whether the problem is solution to this problem is unique or not. So in this this is maximum lemma, and after this I am giving stability estimates also, which will give the solution is bounded, and also this lemma can be proved by taking or constructing two suitable variant functions, just like psi of xt is equal to f norm d over the domain d bar by alpha plus u norm over the boundary of the domain plus or minus u of xt, and this can be proved by using maximum principle. And here also the solution to this problem class also satisfy this following bounds, and that means d for uh, any two positive constants, any two positive constants k and n, satisfying 0 less than equal to k plus 2m less than equal to 6. That means the partial derivative of in time and space with respect to time and space will satisfy, which will be bounded by constant into 1 plus epsilon to the power minus k and minus m. This can be proved by using uh, uh, I think induction method, and then to obtain the um, error estimates, which will more precise bounds for to this problem class, because in the solution we are getting a single a sharp layer, that is a boundary layer, so that we divide the solution into two parts. One is a regular component and another is singular component, and the regular component will satisfy this non-homogeneous differential equation, and the singular components will satisfy this differential equations. And then I established bounds on this regular and singular part also by assuming the coefficient A, B, C, F belongs to C for plus lambda plus and 2 lambda plus 2 plus lambda by 2 over the domain D, and with the boundary conditions I get for all non-negative integers I and j, where 0 less than equal to I plus 2j less than equal to c, the regular part will satisfy delta partial derivative of I plus j over b with respect to delta xi and delta tj, and satisfy 1 plus epsilon to the power 3 minus I minus j, and the singular part will satisfy partial derivative of I plus j with respect to delta xi delta tj, which is less than equal to constant 1 plus epsilon to the power 2 minus a into epsilon to the power minus I e to the power minus alpha by epsilon into 1 minus x. And these two will help us to prove to find the error analysis of our difference scheme. And before that, I discretize the time domain within uniformness. Here 0 to t is the time domain, and minus tau to 0 is the time domain also, because this is for the delay parameter, because in our differential equation there is a delay parameter here. So that's why I am setting in such a way that nt will be n into mt, where for any positive integer n, and in both the domain, the space size is delta t, and then I divide the spatial domain using Siskin mesh by choosing a suitable transition parameter. Sigma is equal to minimum of 1 by 2 epsilon k log n, where k is a positive number here, and I am choosing because to handle the layer region where the layer occurs, where the solution grows very sharply or decay very sharply, to handle this. So, and we divide the domain into two parts. Omega 1 is equal to 0 to 1 minus sigma, and omega t is equal to 1 minus sigma to 1. Then using Then using this two step length, h1 is equal to 2 into 1 minus sigma by n, for I varies from 1 to n by 2, and h2 is equal to 2 sigma by n, for I varies from 1 by n by 2 plus 1 to n. I get the mesh omega bar xn is equal to xi with the node points xi is equal to 2 into 1 minus sigma I by n for I varies from 0 to n by 2, and 1 minus sigma plus 2 sigma into I minus n by 2 by n, where I varies from n by 2 plus 1 to n. And this is the tensor product mesh here. And the boundary points also are denoted d and denoted as gamma n and t. After this mesh discretization, I design the Hoodie finite difference scheme, which is discretized in the following way: ln uij, that is q of delta t uij plus ln x uij, which is equal to qi1 qij1 ci minus 1 j u of xi minus 1 tj minus mt, and minus qij to cij u of xi tj minus mt plus q of f of ij, where the q of bij is defined as qij of 1 bi minus 1 j and qij 2 bij. That means here bij is nothing but at the point of the value of the function b at the point xi tj, or at the node points xi tj, and the operator lxi and ui j is defined as pi ij minus ui minus 1 j pi I c uij plus pi ij plus ui plus 1 j, and the delta t bij is nothing but the implicit Euler scheme bij minus bi j minus 1 by delta t, and the coefficients pi I minus pi ij minus pi ij c plus pi ij plus are defined at the three tensile points, that is xi minus 1, xi and xi plus 1, and qi1 and qi2 are the two coefficients of the identity expansion, are the two auxiliary points, that is xi minus 1, I minus 1 and xi. Here I am taking the auxiliary points are xi minus 1 and xi. Then after, also the identity expansion coefficients qij1 and qij2 satisfy the normalization condition. Under the condition qij k greater than equal to 0 for all k greater equal to 1 and 2. And after this, and these coefficients will be that means pi ij minus pi ij c pi ij plus, and will be exact on the space of polynomial of degree 2, second order polynomial. After solving this, taking the basis function, I got these three equations, and solving these three equations, I am getting the separative value of pi I plus and pi I minus and pi I c. After getting this, the total discrete scheme by applying the implicit Euler discretization onto the Hoodie scheme, I am getting the fully discrete scheme with the condition where we can choose the qij1 if h1 n or greater than equal to 2 epsilon. For 1 I varies from 1 to n by 2, it will be qij1 will be aij by aij plus ai plus 1j, and for h1 n or less than 2 epsilon, in the same I varies from 1 to n by 2, qij1 will be hi minus hi plus 1 by 3 hi and 0, otherwise 0. And then error analysis to see this operator ln uij, this operator will be satisfy A matrix criterion. This operator is nothing but that means at each time level we are getting a n plus 1 by n plus 1 matrix here. So this matrix will that means this operator will satisfy A matrix criterion under the conditions and this lemma tells us let n0 be the smallest positive integer such that k into n naught less than n0 log n0, and b naught plus delta t will be less than equal to alpha n. Under these two conditions, the operator ln will satisfy A matrix criterion, and after this discrete also the operator will satisfy this discrete maximum principle, and this discrete maximum principle can be proved by using M matrix criterion. It is a direct consequence from the M matrix criterion. Then stability estimates. These stability estimates can be also proved by taking suitable, constructing suitable barrier functions and using discrete maximum principle, we'll get this stability estimates also. Then after that, the scheme total discrete for the total discrete scheme or to find the epsilon parameter uniform numerical method, whether I'm the numerical scheme I am used here, whether it is parameter uniform or not. For this, to show this, I need to find the truncation error, and the truncation error is defined given as this tau Eij will be ln Uij minus capital Uij. This is small ui is the continuous solution and capital Uij is the approximate solution. And here we are using the, also we are getting the remainder term, and the remainder term is defined as Rn Fp phi is equal to 1 by n factorial integration a to pi p minus j n phi n plus 1 j dj. And after getting this, I am taking suitable barrier functions here by looking the boundary layer. We are taking phi ij of gamma is equal to product of n equal to I plus 1 to n capital N 1 plus gamma hn by epsilon to the power minus 1 for I varies from 0 to n minus 1, and to I equal to 1 it is 1, where gamma is a positive constant here. Under this, under the condition 0 less than gamma less than alpha by 2 and qij less than equal to aij by ai minus 1j plus aij, for I varies from 1 to n by 2, the barrier function will satisfy this condition. And also so
Hello.
Yes.
Hello.
Yes.
Kindly complete it within 2 or 3 minutes.
Okay, sir.
Okay.
Okay. After these two this barrier function, I am decomposing the solution, approximate solution, into two components, a regular and singular part, and these two will satisfy this equation. After this, I am getting the error estimates for the regular component is ln b minus capital B at the point xij, which will be less than equal to constant to delta t n to the power minus 2 plus epsilon n inverse for I varies from 0 to n by 2, and delta t plus n to the power minus 2 for I varies from 1 by 2 plus 1 to n. And in the regular layer component, I am getting this bounds, and after this also I am giving the error epsilon uniform error estimates for the approximate solution. Here U be the classical solution to the differential equation, and the capital U is the approximate solution. Then the error associated with the given with the discussed numerical scheme is nothing but which is bounded by delta t plus n to the power minus 2 plus epsilon n inverse plus. That means it is first order accurate in the time direction and the second order accurate in the space direction with a logarithm factor. And after this, I want to construct higher order scheme. For that, I need to I am using Richardson extrapolation scheme in the time direction by dividing the mesh delta to delta t by 2, and this is u star is equal to u2 xi minus u1 xi. This is the Richardson extrapolation scheme. And after this, this is uk xi for k equal to 1 to 2. This is the extrapolation after using extrapolation. Then to verify this, also I am also mentioned here the uniform error estimates also for after using Richardson extrapolation scheme, which is second order accurate in both time, space and time with a logarithm factor in the space direction. To verify this, I am taking this numerical results, numerical example. After this, I am, because in this case, this example does not possess any continuous solution. So I am using double mesh principle here. So these are some technical results for the use of double mesh principle. Then after this, taking same number of mesh points in space and time direction. So I am getting almost first order accurate by using before the Richardson extrapolation. Here, Woody scheme is a second order accurate differential. Sorry, Woody scheme is a higher order scheme. For that, to verify whether my scheme is second order accurate in the time direction, sorry, space direction or not, I am finer the time space and cursoring the space mesh. So at the result, I am getting almost the second order accurate, because in the space direction I am getting a logarithmic factor. That's why I am getting 1.8, 1.9, 1.9. That means my higher order Woody scheme is second order accurate, which verified this tabulation. And after this, after the use of Richardson extrapolation, by taking same number of mesh points in both space and time direction, also I am getting 1.8, 1.9, also second order accurate. That means it is verify our theoretical estimates. Also, I am comparing this my result with the results of David Kumar and Kumari, which is, that means my scheme is much more better than their scheme. And this is the solution plot. That means in figure B, I'm taking here two solution plots. One is for epsilon equal to 1, another is for epsilon equal to 2 to the power minus 10. When epsilon decreases, that means their layer appears at the point x is equal to 1 at the right lateral surface. That means it is in first figure it is smooth, but in second figure there is a sharp layer. And this is the log plot. That means the red line is for the Woody scheme, and blue line is the after use of Richardson extrapolation. This shows my also my scheme is second order accurate. Already I have discussed this. So these are some reference. Thank you. Any question? Hello.
Any question from audience? Hello.
No, sir,
Am I
no
audible or not?
Yes.
Yes, yes, you are audible, sir.
Yes.
Is there any question? I think there is no question from audience.
Lalit sir, I guess may want to ask something. Lalit sir, are you there?
Yes. So, Dr. Sahu, it's an excellent presentation. I would like to ask you, what are various applications you can see and how these applications might improve with the method you have proposed?
Actually, sir, these problems arise in many mathematical models. These problems time delay, singular cutoff problems from variety of areas, just like cell division, biological system also. So actually, my aim is to find a higher order scheme which gives better accuracy, which gives less amount of error and gives higher order convergence.
Okay, so this proposed method will optimize the solutions of these problems.
Yeah.
Okay. All right. From audience, any other question? All right. So we can move to the next presentation.
Yes, yes. So it's a good presentation, dear Sanjay. So we should move for the next author with paper ID 70, Saurabh Kumar.
Yes, sir. Yes, sir.
Okay, so start your presentation.
Yes, sir. Good afternoon, everyone. Myself, Saurabh Kumar from LNM Institute of Information Technology, Jaipur. My presentation title is Numerical Approximation for Fractional Order Non-Local Boundary Value Problem via Operational Matrix Method. So my outlines are first.
Please share your presentation.
My outlines are introduction.
Saurabhji, you need to share your screen.
Okay, sir. One second. Sir, please wait for 1 minute.
Okay.
I think some technical issues are there.
What problem you are facing? What problem are you facing? Please let us know.
Sir, please wait 5 minutes. It is some.
Vinith, you can see there is a button called shared screen, share screen.
Yes, sir, but
We have enabled share screen. You just click on that, open your PPT on your system, and it will start sharing. No problem.
Okay, sir.
Saurabh ji, what is the problem? Please let us know so that we could help.
सर ये मैकबुक में थोड़ा दिक्कत आ रही है. Can you give me 5 minutes, sir?
All right. So you keep trying. Shyam sir, I guess in the meantime, next presentation.
Yes, we can start the next paper presentation.
I think Vakil ji is ready.
Paper ID 41.
Hello.
Paper ID 41.
Hello.
Hello.
Yes,
Hello,
Vakil
sir.
ji. Vakil Kumar
Yes, sir, I
ji.
am audible.
Yes, perfectly.
Yes,
So
yes, sir, yes, sir.
you can start your presentation.
Yes, okay. Myself is Vakil Kumar, and here I present a through replacement model, best replacement type of university bus.
Vakil ji, share your
And
screen.
Yes. Through replacement model, a screen is there. Here I shared a screen.
Yes,
Hello.
now it is.
Hello.
Yes, it is visible.
Yeah, but this is a paper, or are you planning to present this way only, or you have some PPTs?
PPT are not so I present this in word form.
Okay, that's all right.
My paper title is through replacement model, best replacement type of university was when whose running cost increase each time, and in this at this time the value of money is constant. In this year, the study of this replacement of items, when items get deteriorating with time and maintenance cost increase. When any equipment requires high repair cost and operating cost, then it needs to replace for economic views. Here we take data for university bus and who's running running 1 year in 180 days, and some journals we here studies through replacement model to determine the appropriate time of replacement deteriorating industrial equipment, and others journal here is a study and my model is here when time t is continuous variable and time t is discrete variable. Here we take a Cn some notations. Cn equal purchase cost of new items and Si equal scrap value of the items at the end of TS, means any equipment replaced at the end of TS. Re equal running cost of items and N equal replacement age of the item. Here we discuss two cases. First, continuous, when T is continuous variable, then the items is used for 3 years, then the total cost incurred over this period is given by TC equal purchase cost minus scrap value at the end of the TS or plus running cost for TS. And purchase cost denoted Cn, and scrap value of the end of the time is denoted Si. And running cost every year is taken 0 to n RT dt. Here we find the average cost. Average cost ATCN equal 1 by n and Cn minus Si plus 0 to n RT dt. And then here we find the minimum cost for differentiating this is then dt dy dt equal ATCN equal 1 by minus 1 by n square Cn minus Si plus Rn by n minus 1 by n square 0 to n RT dt. And if this is minimum, then dy dt ATCN equal 0. Then here we find the value of Rn 1 by n Cn minus Si plus 0 to n RT dt when n is not equal 0. And then we get Rn equal ATCN. This is replace the time items when the average annual cost for n years, because the equal to the current annual running cost, then Rn equal 1 by n Cn minus Si plus 0 to n RT dt. And this is when t is a discontinuous time, and here if t is a discrete variable, then total cost equal Cn minus Si plus summation t equal 0 to n Ft. And average cost is ATCN equal 1 by n Cn minus Si and plus t equal 0 to n Ft. And if here we find minimum of ATC if satisfy these inequalities, ATCN minus 1 greater than ATCN and less than ATCN. And this gives the ATCN minus 1 minus ATCN greater than 0 and ATCN plus 1 minus ATCN greater than 0. Now here we find the ATCN n plus 1 times, and this values gives here we put the n equal n plus 1, then 1 by n plus 1 Cn minus Si plus t equal 0 to n plus 1 Ft. And then we get ATCN equal n by n plus 1 ATCN plus Fn plus 1 divided by Fn. Now we use this result, then we get the values ATCN minus ATCN equal minus 1 by n plus 1 ATCN and this. Then we use these inequalities ATCN plus 1 minus ATCN greater than 0, then we get Fn plus 1 greater than ATCN. And also similarly we find ATCN minus 1 minus ATCN greater than 0, then we get Fn less than ATCN plus 1. Then we get following results. Item will be replaced if n plus 1 greater than ATCN. This implies Fn plus 1 greater than 1 by n Cn minus Si plus summation t equals 0 to n Ft, and will be not replaced if Fn less than ATCN minus 1, implies 1 upon n minus 1 Cn minus Si plus t 0 to n minus 1 Ft. Here we taking some data. Here we taking data are 2000 and 17 years data here we collect. In first distance travel per day, any university bus distance traveled per day is 64 kilometers, then distance travel yearly 13,440, and diesel cost here take a 28.22 rupees. Then total diesel cost per day, here we get total diesel cost 141.10, and yearly diesel cost is this, and other cost is here we take 6,000.00. Then the running cost is this. This is first year running cost 31,398.00. Here we take a second year. Similarly, second year, third year, here we get 17 years data, and then we use the model year of service, first year service, and depreciation cost in any equipment working. Then day to day the work characteristic is decreases. Then and here we take depreciation cost this, and running cost this, and cumulative running cost, and total cost. Then average cost is this. In this table we see, then see after 16 years the average annual cost is increased. Then in economical view, the bus is replaced after 16 years, means end of 16 years, because the 17 years the average annual cost is increased. Then we conclusion in this study, through replacement model we determine the appropriate time to replace the depreciating equipment when maintenance and repair costs increase with time, ignoring changing the value of money. And some references here. Thank you. Hello.
Okay, so any question from the audience? Hello. Hello, any question?
Oh. Mr. Vakil Kumar, it's a brilliant presentation.
Yes, yes.
Now, can you calculate exactly when it is the best time to replace the item?
Here we get 16, end of 16th year. 16th year. If after this the cost is, yes, yes.
The problem here is the fuel price, the price of vehicle or price of new items, everything might change with time, and you
Yes,
are
yes,
taking
yes,
exactly
yes,
same price for.
Yes. No. Here we diesel cost is here 28.2 is 30.4, 31.7, and
So
other cost is
average
maintenance cost.
Average means
If any,
per liter. Diesel cost per liter.
Hello.
Yes,
Yes, per liter.
you are writing diesel cost average, which is diesel cost per liter.
Yes. Here
Okay.
diesel cost is taking average.
Yeah, average means per liter. What do you mean by average? So this
average means are numerical values which represent the overall data.
But is it per kilometers or per liter?
Per
Hello.
Hello.
Yes. So
Here,
is it kilometer?
Diesel cost 28 rupees, 28.22. Then diesel cost per day. Per day means bus is running 64 kilometers per day.
Okay.
Then one
So that's per kilometer.
one day is 141. Yes, yes. And then
No.
total diesel cost yearly. Yearly
No, I
diesel.
don't think that is per kilometer, because if you multiply 64 by 28, it will be more than 141. So that might be
This
per
is
liter.
per day.
Yeah, but how you calculate it?
28 point.
Anyway, my question is, your demand might change, your diesel price might change. Okay, so that's per liter diesel price. So how this model might work with that dynamic? Okay, so because everything is dynamic, even your requirement, you are taking a simplistic approach where total distance travel yearly is the same for each year, but these things might change. Also, roads might change, so the fuel consumption might change based on roads, quality of roads.
Yes, yes, sir.
So
Now
can we
I
use
will tell
linear
you
programming there? Because popular methods are linear programming or optimization.
no, no.
All right, anyway, it's a nice presentation and a very interesting problem and a realistic problem. All the very best.
Thanks.
Now the next authors, Saurabh Kumar, paper.
Yes, sir. Yes, sir. Now my side is visible or not?
Yes, but you have not
Hello,
yet shared
Saurabh.
your.
Yes.
So, are you able to share your screen?
Yes, sir. Yes. It is visible, sir.
Yes.
Yes, it is visible.
So good afternoon, everyone. Myself, Saurabh Kumar, from LNM Institute of Information Technology, Jaipur. My presentation title is Numerical Approximation for Fractional Order and Non-Local Boundary Value Problems via Operational Matrix Method. The outlines are these. So first we introduce fractional calculus theory. Fractional calculus is an ancient topic of mathematics with history like as ordinary or integer calculus. Theory of fractional calculus is developed by N. H. Abel and J. Lively. The details can be found in reference 1. In last few years, fractional calculus has attracted attention of the researchers of medical physics, chemistry, biology, engineering, and mathematics. Fractional calculus and fractional differential equation are found in many applications in different fields. Fractional calculus is the generalization of ordinary differential and integration to arbitrary non-integer order. Within years, the fractional calculus became a very attractive subject to mathematicians, and many different forms of fractional differential operators were introduced as the Gunwald Latinico, Riemann-Lively derivative, Hadamard derivative, capital derivative, and others. As there are many difficulties to solve a fractional order differential equation by analytic method, So there is need of seeking numerical solutions. There are many numerical methods available in literature. Eigenvector expansion method, Adamian decomposition method, and others in reference to 5.3 and 4.5. So we are working on the operational type methods of non-local boundary value problems. The non-local boundary value problems are getting much attention from researchers due to their wide application in physical, biological, chemical, and engineering science. Non-local boundary value problems are those in which the solution is not known at the boundary points of the domain, and boundary values are associated with the solution at the interior points of the domain. Such types of problem appear in modeling of pressure transition of solid single species population dynamics with non-local effects. Ohmic heating non-local boundary value problem, non-local reactive transport with physical and chemical heterogeneity. For more application of non-local boundary value problems, one can see reference 10 and 11. We consider the following class of non-local fractional order boundary value problem in reference 12 with derivative mu with this fractional differential equation, ordinary fractional differential equation with the non-local boundary condition. Non-local boundary condition is in the form of summation, where d mu denotes the capital derivative of order mu, and mu belong to interval 1 to 2. R is the positive integer, and I belong to 0 to 1. Coefficient bx and cx are given continuous function in interval 0 to 1, and gx is given in such a way that the problem first is a unique solution. Fractional Riemann-Lively and capital fractional operators. So fractional integration of Riemann-Lively types of given order gamma of a function ft is given by this. Fractional derivative of Riemann-Lively type of order gamma greater than to 0 can be defined as d gamma is equal to dy dt power m I raised the power m minus omega f of t, where gamma greater than to 0 and gamma lie between m minus 1 to m. Fractional derivative of order gamma greater than to 0 in capital sense can be defined as in the form of this. When gamma is equal to L, then it is equal to dl ft over dtl. And when gamma lie between L minus 1 to L, then it is defined as in the form of this. Generalized Taylor formula. Suppose dk omega hx belong to in C01 and k is equal to 0, 1, k from 0 to n plus 1. Then we have h of x is equal to summation from s is equal to 0 to n x to the power s omega upon gamma s omega plus 1 ds omega h0 plus x power n plus 1 omega y gamma n plus 1 omega plus 1 derivative of h omega, where I belong to 0 to x, and derivative of n d की power n alpha is equal to d alpha n times product of d alpha n times. Moreover, modulus of hx minus summation s is equal to 0 to n x to the power s omega over gamma s omega plus 1 d of s ds omega h of g h0 plus is less than equal to m omega x to the power n plus 1 gamma over gamma n plus 1 omega plus 1, where m omega greater than equal to supremum of this modulus. So the Lagrange polynomial, now we define Lagrange polynomial of fractional order alpha, where alpha belong to a semi-interval 0 to 1. On the mesh point xi belong to 0 to 1. I is equal to 0 to n is defined as follows. Li alpha x equal to summation of s is equal to 0 to n 0 to n psi I s x power alpha n minus s for all I is equal to 0 to n, where psi I 0 is equal to this, and psi s is equal to in the form of summation in the summation r1 is equal to 0 to rs is equal to rs minus 1 plus 1 to n, where I does not belong to r1 and r1 does not to r2. These are not equal to each other. Suppose L0 to L1t and Lnt is a subset of L square 0 1 is the set of fraction order Lagrange polynomials. A function ut which belong to L square 0 1 can be expressed in terms of fractional order Lagrange polynomials as in the form of this: u of t is equal to summation L is equal to 0 to n CL Li alpha t is equal to Ct L alpha t, where CL is equal to inner product of ut and L alpha t, and the C and alpha t are column vector. Operational matrix of integer order derivative. To find the operational matrix of integer order derivative, we use the Taylor function of fraction order defined as in reference 15. Pi alpha x is equal to x की power I alpha, where I is equal to 0 to n. The Lagrange polynomials of fraction order in terms of Taylor function can be written as L alpha of x is equal to r into f of alpha x, where p alpha x is equal to the column vector 1x x alpha x n alpha. Where p alpha x is equal to transpose of the vector, and r is n plus 1 cross n plus 1 matrix defined by this. Now differentiating L alpha x with respect to x, we get dl alpha x is equal to dr p alpha x is equal to dy dx r p alpha x. We outside r because r is an n plus 1 cross n plus 1 matrix. So dy dx r dy dx p alpha x is equal to x की power minus 1 r h r minus 1 l alpha x, where h is also a matrix of order n plus 1 and giving n plus 1 cross n plus 1. Here is some mistakes and given by this. Let x minus 1 rh r minus 1 is equal to q. Then q is called the operational matrix of first order derivative. Similarly, one can obtain the operational matrix of integer order derivative of order m greater than to 0 by considering dm alpha x equal to x minus m rh r minus 1 l alpha x, where h is equal to the element of hij is an n plus 1 cross n plus 1 matrix given by this. Operational matrix of fractional order derivative. In previous slide, we discussed operational matrix of integer order derivative, and in this slide, we discuss operational matrix of fractional order derivative. To determine the operational matrix of fractional order derivative mu, we differentiate the Lagrange function L alpha x as in the form of this: d mu L alpha x is equal to d mu because L alpha x is equal to rp alpha x. So this is equal to d mu rp alpha x, where r is the matrix of order n plus 1 cross n plus 1.
Hello.
Yeah,
Mr.
yes, sir.
Saurabh.
Yes, sir. Yes, sir.
Within
Yes, sir.
completed 2 or 3 minutes.
Okay. So we here, as similar before, we can get the operational matrix of fractional order derivative, where h1 is equal to defined as in the form of this, and q1 is equal to x power minus mu r h1 r inverse is called the operational matrix of fractional derivative of order mu. The proposed method for fractional order Lagrange operational matrix of fractional differentiation. So first we approximate the solution ux in terms of the Lagrange polynomials Ux approximate as C transpose L alpha X, where C is a column vector and defined as this. Furthermore, differentiation of the equation at with respect to X, we get this U dash X equal to X minus 1 C transpose Q L alpha X, where Q is the operational matrix defined in slide. Well, now we define the fractional order derivative of order mu by differentiating the equation 8 with respect to X as follows this. So we get d mu Ux equal to X power minus mu C transpose Q1 L alpha X, where Q1 is the operational matrix of fraction number. And by substituting equation 8, 9, 10 in equation first, we arrive the following equation, and from the initial and boundary condition of we get this. So now collocating the equation 11 at the nodal points xi is equal to I by n, where I is equal to 0 to n, and with the help of equation 12, we get a system of linear algebraic equation, which is solved easily to get the entries of the unknown vector C. And so finally we obtain the approximate solution Ux. In this slide, we discuss example first, where fractional order derivative here we take the mu equal to 1.3, and the exact solution of this problem Gx equal to x square, and absolutely error is calculated within the exact and approximate solution for our using our purpose method for n is equal to 4 and alpha is equal to 0.1. So at the point 0.1, the absolute error is this, and 0.3 and so on 0.9. For example 2, mu is equal to 1.6 here, and non-local initial and boundary conditions are these, and exact solution of this in table 2, the absolute error at different nodal points are given, result and discussions. So from table 1 and table 2, we get a very good result. And in figure 1, plots of approximate solution and exact solution. For example, first with n equal to 4 and alpha is equal to 0.5. The approximate solution is in red color and exact solution is in blue color. For example 2, the plot is given for alpha is equal to 0.9 and n is equal to 5. And absolute error at different nodal points x of the domain with the values of n belong to 4, 3, 4, 5, 6, for example first. So we get a very good accuracy for both examples by this operational matrix method. So in this article, 3 important goals have been achieved. First one, the use of collocation method based on fraction order Lagrange polynomials to solve the fraction order boundary value problem in the presence of non-local boundary condition. Second one is the absolutely error which is almost 0 for the small number n of fraction order Lagrange polynomials. In future, I will investigate non-local boundary value problems with integer, fractional, and variable order with the help of different type of operational matrix method. So here is some references.
Okay, Saurabh, so it's a
Thank
nice
you.
presentation.
Thank you,
So
sir.
any question from audience? Hello. Any question from audience? So I think we should start the next presentation. Okay, thank you, Saurabh, for your nice presentation. Okay, no questions from audience.
Shyam sir, Prem has joined. So like if you want,
Yes,
like you can.
Yes. So paper ID 4033. 33 Prem Kumar Karan. Prem Kumar Karan.
Yes, sir.
paper-
Yes, sir. Yes, sir.
Okay, so please, it is requested to complete your presentation within 8 to 9 minutes.
Okay, sir. Thank you.
Premji, you need to share your screen.
Yes, sir. देखे तो सर से नहीं हो रहा.
Just open your PPT in your system and enable the share screen option. You'll be able to share.
इस पहले वो निकालिए ना, खोलिए फिर.
जूम यही है ना, मैं कंट्रोल्स में दे दे
ये
हटिएगा मत, तू खड़े नहीं आ रहे हैं.
At the bottom, you can see share screen option.
bottom. Share screen option. जी.
अलाउड है गूगल
प्रेम जी,
यस सर.
कर पा रहे हैं शेयर स्क्रीन की प्रॉब्लम आ रही है?
1 मिनट सर.
बहुत इजी है, इट्स वेरी इजी. आप अपनी पीपीटी अपने सिस्टम पे ऑन कीजिए और शेयर स्क्रीन पे जाइए, उस पर क्लिक कीजिए.
शेयर स्क्रीन
नीचे आ रहा है, बॉटम पे आता है, देखिए.
स्टार्ट नाउ कर रहे हैं तो डिस्प्ले और अदर ऐप होता है. अदर ऐप में
शेयर इंटायर स्क्रीन का ऑप्शन कीजिए.
प्रेम, जहाँ पर म्यूट अनम्यूट का ऑप्शन होता है वही थर्ड ऑप्शन होगा शेयर स्क्रीन ग्रीन कलर से. म्यूट अनम्यूट करते हैं, जहाँ से वीडियो स्टार्ट करते हैं वहां साइड में देखिए शेयर स्क्रीन लिखा होगा. So Varun sir, I would suggest like he can start reading from his side if he is not able to show his screen. Like we are okay with that. What do you suggest?
Yeah, I think the same. If he's not comfortable today, we could reschedule his presentation tomorrow also, because we are already running short of time.
Hello.
Yes.
Okay, sir. Hello. Sir, I can't share.
No problem. No problem. We could reschedule it later on. So Shyam sir, I think we could wind up.
Yes. So we must wind up right now because the time is also over. And due to some problems, some authors are not able to present their papers. So we have rescheduled their papers.
Right.
Okay. So thank you all
Okay.
for the time.
Thank you, Sham sir. Like I appreciate the efforts of all the paper presenters and session chairs for keeping it informative. So grateful for your time, Dr. Garg. I would like to invite you to join our next keynote speech scheduled at 1:30 p.m. today. So if you are comfortable and have enough time, you can join us back. Thank you for your time again.
Just a second, Garima ma'am.
Yes, sir.
I would like to express my special thanks to Lalit sir because he's in Malta.
Okay.
And it's very early morning there. So apart from all difficulties and obstacles, he's somehow managed to chair the session. My very, very special thanks to you, sir. We are
Thank you very much, Varun and Garima.
We are so grateful to have you as a chair. It's our privilege, sir.
All the very best to all participants. It is indeed a great pleasure to meet you all and wish you all the very best.
Thank you again.
Thanks a lot, sir. The next keynote will be of Dr. Satish Kumar Singh, sir, from IIIT Allahabad.
Right.
And the topic is deep learning architectures and its applications. So I request all the participants to join on scheduled time.
1:25 p.m. sharp, so that like we can start by 1:30. All right. Thank you.
Thank you, sir. Thank you. हाँ हाँ, मैं अभी आपको को होस्ट बनवाता हूँ जी, आप दिखें बस मुझे। हाँ आ गए सर, आप सतीश कुमार सिंह जी। हाँ मैं करवाता हूँ। मनोज सर, मनोज सर, yes yes, kindly make host to Satish Kumar Singh sir, co-host. Ma'am, I think we can start now.
All right. So we have enough participants.
Sir has already joined.
All right. So good afternoon, everyone. I, Dr. Garima Williams, again, on behalf of PSIQ organizing team and technical sponsors, ISTE and IEEE chapters, welcome you all to the International Conference on Computational Mathematics and Engineering Applications. I take pride in extending a cordial welcome to our keynote speaker, Dr. Satish Kumar Singh Sir, Associate Professor, Indian Institute of Information Technology, Allahabad. Earlier, he worked with the Department of Electronics and Communication Engineering, JP University of Engineering and Technology, Guna. He has about 16 plus years of professional experience in various capacities. His areas of interest include image processing, computer vision, biometrics, deep learning, and pattern recognition. Presently, he is heading the Computer Vision and Biometrics Lab at IIT Allahabad from 2015 onwards. He has supervised 6 PhDs and 34 master's students in his research career, and presently 9 PhD and 6 master's students are pursuing their research under his able guidance. Dr. Singh and his group published about 60 research articles in various IEEE, ACM transactions, journals, and international conferences of repute. He is the co-principal investigator of many projects funded from various government funding agencies, that is Ministry of Defense, Ministry of Education, and Home Affairs, Government of India. Dr. Singh is holding the responsibilities as local coordinator, Global Initiative of Academic Network by MOE, Government of India again, Nodal Officer, Scheme for Promotion of Academic and Research Collaboration, Ministry of Human Resource and Development, Government of India. He is also the founder and the present faculty counselor of IEEE student branch, IIIT Allahabad. Under his able guidance and supervision, many awards and laurels like the Indian Council Student Volunteer Award, Section's Best Student Award, Largest Student Branch Award, and 2 IEEE MGA Richard E. Marvin Scholarship has come to the SB and section as well. His areas of interest lies in machine and deep learning, data compression, image processing, biometrics, watermarking, retrieval, thermal imaging, visual sensor network, thermal object detection, and recognition. So let's listen to Dr. Singh's talk on deep learning architecture and its applications. Over to you, Dr. Singh.
Ma'am, with your permission, I want to add something.
Yes, sir.
Sir is also currently the chairman of IEEE UP section.
Oh, congratulations, sir. Glad that you are here amongst us and you could manage this much time for us.
I'm very happy to share with all of you that he is the person who taught me the ABCD of electronics and communication.
All right.
So it's a great day and great privilege for me to listen to you, sir, once again. Most welcome, sir.
We are looking forward to listen to you, sir. Please.
So, thank you, Dr. Garima, for a nice and elaborated introduction among the audience. Thank you, Varun, for recognizing me, at least for some reason. So, thank you. So, not taking much time, let me share the screen. Varun, is it visible?
Yes, sir, perfectly.
Okay. So, so as highlighted by Varun, so basically, mostly the participants are young in this particular conference. And a lot of people from electronics and communication engineering and other branches are also participating in this conference. So, although the theme of the conference was mathematical application in engineering discipline, basically, in variety of fields. But somehow, I think that without mathematics, nothing can be done in engineering. So, knowingly or unknowingly, okay, whether you want or not, mathematics will be there, and we cannot avoid the presence of mathematics in any scientific or technological developments. So with these lines, let me introduce my title for today's talk, that is Deep Learning Architectures for Signal Processing Applications. So I thought, okay, this may be little appropriate for today's audience. So since here I started the research in the domain of deep learning at IIIT Allahabad, and more than 9 PhDs completed in this particular domain. So now I believe that this is quite matured here at IIIT Allahabad. So, but the content of this talk is not very deep. In a sense, I just want to introduce the topic to the audience and just to sensitize that where these deep learning architectures will be useful and whether we are convinced or not, but later or sooner we have to be convinced that this field of deep learning, application of deep learning will cover entirely, all the fields of science and technology. So be prepared. So whether you're doing research in communication or signal processing or any field, data analytics, everywhere, ultimately we will be bound to consider the applications of deep learning in all those domains, wherever we are working. So disclaimer, the content, we don't have the copyright because we have taken the content from a variety of sources. So basically, the authors of this material do not claim any copyright of any material, whatever is being displayed. This is used only for pure academic purposes. So let us start. So some essential points. Let me introduce the term artificial intelligence, basically. So nowadays this is buzzword, and all of us are listening and talking about this artificial intelligence. But as per my experience, I introduced this term artificial intelligence, which is equivalent to two other terms, that is learning and generalization. So normally people think that AI is analogous to the machine learning or simple learning. But if we go in little detail, then we can find out that AI is not only the learning, but the generalization also. What is the difference between the learning and generalization? Okay. Suppose we learn, suppose a kid is learning at very beginning. Okay, so what happens? We used to present the examples. Okay, and with these examples, with time, the kid used to learn. Okay, say whether this is apple or not. I usually take the example of how kid used to learn the apple. How the kid can know that whether this is apple or not. So what happens? You show the apple and tell them, okay, this is apple. Okay, if you say only once, then maybe after a long time, the kid may forget, okay, what was it? There was no clue. So normally how learning happens? Repeatedly, you present the apple to the kid and tell them, okay, this is apple, this is apple, this is apple. So eventually what will happen? The kid will learn that this is apple. Okay. So normally in all kindergarten and other classes during the studies, this happens, and the kids used to learn many things. This is simply the learning. But who is intelligent and what is the intelligence? Learning without generalization is actually not the intelligence. Okay. So what is generalization? You have presented the, the apple with variety of pinkish color, red color, maroon color, or slightly yellowish color. So variety of apples which are actually found in India, you can present to the kid, and kid can, okay, learn that this is apple. But someday this kid can see which is actually a green apple. And in past, the kid never saw this apple. Then how this kid will know that this is apple or not? So here there is a use of real intelligence. Okay, on the basis of past experiences, the kid or the person can predict that this is actually apple. Although this apple was never presented or never shown to the kid that this is apple. Okay? So this is basically generalization capability. It means to predict something or to know something without having prior encounter. Yeah, it means in earlier no such data was presented. Even then, the machine should be able to predict. So this is basically the generalization capability. So artificial intelligence is learning plus generalization. So I have already taken this example how kid learn apple, but there is a situation, okay, when you present only apple throughout the life. Okay, you present apple, 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 all sort of apple, and every time you simply present the apple, then what happens? What happens? After some time, you present some different fruit. Even then, the kid will say that this is apple. Okay. It is very practical. It is very, very practical. Whatever you show to the kid will say that this is apple. What is this problem actually? This is a problem of overlearning. Overlearning. Or you can say this is a problem of overfitting in terms of the machine learning vocabulary. What it means, I just want to correlate that human learning and machine learning are not different. Both are almost same. And somehow machines are trying to match the humans. That's why there is a need. Okay. So artificial intelligence, yes, earlier how the intelligence was created basically in the machines. So some rule-based systems were there rather than simple programming or calculation. Earlier only calculations were there. Computers were treated as calculators only. After that, some sort of automation. And after that, what happened? Some rule-based systems were there so that machines could take some decisions, and some sort of intelligence was included in the machines. So basically, all sort of rule-based systems comes under the category of earlier or ancient, you can say somehow, artificial intelligence. Then machine learning came into the picture. So artificial intelligence was basically governed by the models, mathematical models, or some rule-based models. Okay. But in case of the machine learning, what was happening means rather than making the rule-based models, some trainable models were designed. It means somehow was it possible to take a decision on the basis of the experiences. So that's why machine learning came into the existence. Okay. But in case of the machine learning, yes, if you want to train the machine, then every object was required to be presented well. It means some sort of feature vectors or features were important. So that's why feature engineering was very much required in case of the machine learning. So wherever you want to apply the machine learning, at least you should represent the data with a suitable feature vector. And this feature vector will be used to train the machines. Okay. So this was a thing. And this is a new term, that is deep learning. Nowadays it's buzzing and everybody is willing to do something in the domain of deep learning or the application of deep learning in variety of other domains. Okay. So deep learning here, in case of the machine learning, feature engineering was important. And somehow the learning was not end-to-end. But in case of the deep learning, there is no feature engineering involved. It means whatever complex object is there, or object scene is there, or signal is there, or data is there, it is not required to represent in suitable format. So feature engineering was not important, but the features were learnable in nature. It means everything is learnable in case of the deep learning. So with the help of experiences, the system itself will learn how to present this experience or data and how to utilize this presentation, or you can say the feature vector, in the best possible way. So this is the transition from machine learning to deep learning. And now, what is the future actually? So now people started talking about the cognitive inspired. This is the first term. The second one is emotionally intelligent deep learning. Cognitive inspired, emotionally intelligent. So now there is a A contradiction. Contradiction is cognitive inspired means the decisions which are based on cognition, and all the cognitive decisions are mostly biased in nature. So we want the totally unbiased machine. But at the same time, we are saying it should be cognitively inspired decision. Okay. So basically, we can say that somehow people are trying to exploit the human behavior. Okay. Human behavior which is affected by some internal things, means intrinsic, as well as some external things, maybe your friends, maybe the environment, maybe the situation, maybe the country, maybe anything. These are external factors. So how to include, okay, how to include the effect of those intrinsic and extrinsic factors while taking the decision. Got it. So this way, people are trying, now people have started talking about these kind of machines. So more advanced deep learning architectures are being proposed by people. So this is just one development from normal artificial intelligence to cognitive inspired emotional intelligent deep learning. So just an introduction about the machine learning and deep learning. Yes, in case of machine learning, here we can observe that feature engineering is important. It means somehow a suitable data representation is must in case of the machine learning. And then this data representation means these feature vectors can be used to train the learning algorithms, or to train the algorithms, or to learn something, learn from feature representation. Okay. So this way here, it may be any classifier or regressor or cluster or whatever. Means any application can be used here, but on top of the feature engineering. So feature engineering is important. So what is deep learning? Already discussed. A machine learning subfield of learning representations of data. Learning representations of data. It means how to represent the data is not the problem for the humans, but problem for the machines itself. So this is the responsibility of machine to represent the data in the most suitable manner. Okay. So exceptional effective at learning patterns. So basically nothing is required to be generated basically. So everything is learnable in nature in case of the deep learning. So deep learning algorithm attempts to learn multiple level of representation by using a hierarchy of multiple layers. So normally there is a question, which model should be treated as the deep learning models? Suppose you have taken 100 layer neural network, whether this is deep learning network or not. So there is a question. I mean, this is a valid question. When a model should be known as a deep learning and when it should not be treated as a deep learning model. It means it is not governed by completely on the basis of, number of layers cannot decide whether this is a deep learning or not. It means there should be some hierarchical representation of the features. It means there should be some abstractive concept or abstractions. What do you mean by abstraction? Abstraction is simple. You consider any image, then what you will find, there is a pixel. If you correlate with the neighboring pixels, you can find, okay, whether this is a dot, whether this is a line, whether this is an edge, or there is a curvature, these kind of features. If you combine these bigger features, then what will go? What you will come to know that whether this is circle, whether this is rectangle, or these kind of features. If you combine these features, then you will get the complex objects and even more complex objects. So at the topmost layer, the representation is most abstractive in nature. It means somehow abstraction level is increasing from lowest level abstraction to highest level abstraction. Then only the model will be treated as a deep learning model. Otherwise, it cannot be treated as a deep learning model. It may be 100 layers neural network, but you cannot say that this is a deep learning. Okay. So normally people do the mistakes while considering whether this is a deep learning or not. So if you provide a system tons of information, it begins to understand it and respond in useful. So here, in case of machine learning, feature extraction is important. That's why feature engineering is useful. But in case of deep learning, this is the input, this is the output. What is happening inside, okay, is not of much concern. But yes, for the designers, it's of concern. Okay, how to design it. So learning, so improving performance through experience. Okay, improving performance through experience. So experience matters actually. It means how much time has been spent for learning anything. Okay, so if you say there is task that you need to learn from single signal or single image, what is happening means what is the story behind this image. Okay, there may be some story. Earlier in newspapers, there was some scene, and it was expected from the readers to write some story and to send the publishers, and they used to award for the best story. Okay, means the best description of the scene. Okay, so if you want to write the story, then you need to put sufficient amount of time to understand what is happening behind the scene, which is actually not set. So if you visualize these kind of scenes in repeated manner, so this is actually the role of the experience. With the help of experience, you can represent the data in very effective manner. If you don't have the experience, somehow the generalization capabilities will be lost. Okay, so in case of learning, improving performance through experience. If it is not happening, so improving performance through experience. So how machines will show this thing? It means if you design the machine, so initially the level of error may be very high, but if you present the data again and again to the machine, means you present the same example or same experience, then the level of error should decrease. It should, behave very properly. So this is the meaning improving performance through experience. It means earlier at very beginning error may be very high, but with experience or with time this error will be almost zero. So this is a meaning, and it exactly happens in case of training a machine learning or deep learning algorithm. Okay, the error is quite high at the beginning, and if you present the data again and again, repeat the operation, then after some time this level of error goes ideally to zero, and then only you can consider that your system is learned. It means it is completely trained. So getting a computer to do well on a task without manually building in competence. So it means it is not required to consider block by block. So what is deep learning? Using multi-layer neural networks. So it is incomplete without the hierarchical representation. Okay, it means multi-layered neural network using the concept of hierarchical representation while moving from lowest level representation to mid level to high level to highest level of abstraction. So what is the relationship between deep learning, machine learning and AI? We have already discussed about this. So why is deep learning useful actually? What is there so that we should consider to develop the deep learning architectures? So normally there are few things. Manually designed features are often over-specified. What is normally, if you have studied about the data mining and other things, then you must be aware of this term, over-specified. Okay, say we need to differentiate. Okay, we need to differentiate a human with a bird. Suppose, okay, we need to differentiate between human and a bird. So there are some clear-cut features like humans are having 2 legs. Yes, birds are also having 2 legs. Okay, humans are having 2 hands. Birds are not having 2 hands. Birds are having 2 maybe wings. Okay, okay. So and there many other things. And if you say okay, humans are wheatish. Okay, then birds are also British. It is quite possible that birds are also British. Okay. Humans are big. Okay. Humans are fatty. Okay. So what are those features? Although these are the features, okay, but actually this is over specification of the humans. Actually, for classification of bird and human, okay, distinction between birds and human, these kind of features are actually not required. So sometimes it happens that rather contributing in the distinction or simple prediction adversely affect the process. It means if you want to classify, then it may contribute to the error rather than contributing to the accuracy. Just opposite is sometimes these features are incomplete in nature. Okay, means some features are lost and take long time to design and validate. So feature engineering is quite complex in nature. Okay, so that's why either under specified or over specified or incomplete or these kind of things are used in case of typical machine learning algorithm. So that's why it's quite cumbersome. Learned features are easy to adapt and fast to learn. What is the meaning of easy to adapt? Say we have designed a network for object classification. Okay, then very easily we can modify this model for the digit classification as well. Got it? Although the model was designed for object classification, now it can be modified for the digit classification very quick. So that's why easy to adapt and fast to learn. Deep learning provides a very flexible, almost universal learnable framework for representing word, visual, and linguistic information. Everything can be represented. It can learn both unsupervised and supervised. So both kind of algorithms or models are possible to be designed with the help of deep learning. And it is very effective end-to-end joint system learning. It means learning representation and learning classification or decision making. Both things will happen together. So that's why this is basically end-to-end learning system. That's why it's quite acceptable in nature. Utilizes large amount of training data. So this is the thing. What do you mean by large amount of training data? It means large amount of experience. Means large number of instances. Large number of instances are presented to any human to learn something. So obviously, if experience is quite high, then the level of accuracy will be quite high. So you consider one simple army. In this army, normally the command is given to the person which is actually very learned. Learned means he or she has seen a lot of data or experiences, gone through the experiences. At the same time, having generalization capabilities. Okay, means for unseen scenarios also the person should be able to take the decision. So large amount of data means that is analogous to huge experience. So if this is a situation, obviously learning will be effective. Means it will be real intelligent system. So what is the problem? There is an issue. If the data is large, so what happens? Take a practical scenario. Take a practical scenario. There is a kid of only 3 years or maybe 2 years, and you show them, these kids, 100 types of fruits. Okay, and every fruit is slightly different. Say there is a mango, then mango, all mangoes are slightly different. Okay, and these kind of 100 types of fruits, then what will happen? Means the kid may be confused. Okay, means although you have presented mango 100 times, guava 100 times, banana 100 times, so there are 100 fruits and every fruit has been presented 100 times. It means there are sufficient number of data sample for a particular class of object of particular experience, repeated experience. Still, kids are not learned in this case. Okay, why? Because of their memory capabilities. It means if there are huge data is very high, very large data, in that case you should have sufficient amount of memory also. Otherwise you cannot contain all those experiences basically. You cannot learn. So that's why it is suggested that while having huge data, okay, just to correlate all those things, you should have sufficient memory space. And this is the reason that deep learning models are required. So means for large data, sufficient memory space, how it can be increased? You can have the wider network, you can have the deeper network. In wider network, hierarchical representation is not possible. But in deeper network, hierarchical representation is possible. It means you should have quite deep networks. Means hierarchical representation along with quite deeper. Means large number of memory elements or interconnects will be available. So that's why this is a motivation. Practically today, for any application, we have huge data, then how to utilize this data to draw some inferences with the help of learning and generalization or with the help of AI. Yes, so this is the motivation behind using the concept of deep learning. So I have already discussed, this is a typical traditional machine learning, some data, handcrafted, feature extracted or feature engineering is used, and then simple trainable classifier. So only this part is trainable. This is hand engineered basically. Okay, so this is typical machine learning. But in case of deep learning, feature extraction is also trainable in nature. Means when say for car, there is a more suitable feature, feature vector, then that can be learned. What are the most suitable feature for car? What are the most suitable feature for the elephant? What are the most suitable feature for the bike? And so on, so forth. It means for each and every instance or data, the most suitable feature can be generated. But how? By learning. So this portion is learnable in nature. This is also learnable in nature. So entire pipeline is learnable in nature. So this is basically end-to-end learning. Similarly, we can talk about this speech signal. So this is typical example of speech recognition in early 90s to 2011. This was typical pipeline. So MEL frequencies, cepstral coefficients were extracted from this speech signal. Then mixture of Gaussian was used in case of, as unsupervised learning, means unsupervised methods, means some sort of clustering need to be done. And then these clusters are fed to the classifier for speech recognition. So this was general pipeline. Similarly, in case of object recognition, this was typical pipeline from 6 to 12. Okay, again here some shift or HOG features. So these are hand engineered features. Then K means sparse coding, just to do the clustering, then pooling the most representative samples, clusters, and then classifier was used. So this was typical machine learning, basically pattern recognition of machine learning pipeline. And if we talk about the deep learning, I have already told that hierarchical representation of the features must be done from lowest level to the highest level of abstraction. So here, this is the scene. So at the low level feature, these are some lines, edges, and other things. And here, just combination of those things and some mid-level feature representation, some structures are coming out. And here, high-level feature representation, clear-cut structures are available here. You can observe all those things. Okay, and then these highest level features are fed to the trainable classifier, and classifier used to learn. So everything means we are not doing step by step, but in one go, this will happen. And if you take out the features after this level, after this level, after this level, then these kind of features are available. That's why this is some typical model of deep learning. So here, feature visualization of convolutional net trained on ImageNet. So this is basically by Giller and Fergus, because this has given another motivation to develop the ZF architecture over the CNNs, VGJ. So feature hierarchy is necessary in case of the deep learning. At the same time, since there is huge data, huge memory is required. So if we take the wider network, feature hierarchy will be lost. To maintain this, there is a single option for having huge memory, and that is to make the network deeper rather than making the network So typical trainable feature hierarchy like image recognition, pixel to edge, to text on, to motif, to part, to object. So this way it will learn. Okay. So these kind of features must be generated through, while moving from the first layer to the last layer. Similarly, in case of the text, character, word, word group, clause, sentence, and story. So at the last layer, it should be simply the story, and that should be fitted to learn, train the model. Similarly, speech, sample, ancestral band, sound, phone, phoneme, word, these things. So everything is trainable basically from input to output. So this is typical trainable hierarchy. Hierarchy means these kind of feature representations are must to qualify a network to become the deep learning network. If it is not, your neural network may be of 100 layers or 200 layers, but it cannot be called as the deep learning architecture or model. So another thing, since this is hierarchical representation, so deep learning models used to mimic the brains actually. This is typical example, some studies have been done. So here, it is perceived, some signal is being perceived, goes to LGN, to V1, to V2, to V4, to PIT, AIT, and PFC, MC, and to spinal cord for some motor movement. Okay, from sensing to motor. But in between, this information will be processed very appropriately, but in hierarchical manner. So monkeys can categorize complex visual stimuli very quickly with reaction time that averages 250 to 260 milliseconds, but that can be as short as 100 milliseconds. Means it's quite in the range of few hundred milliseconds. So information from retina is relayed by lateral geniculate nucleus of the thalamus, LGN, before reaching V1, the primary visual cortex. From there, processing continues in areas V2 and V4 of the ventral visual pathway before reaching visual areas in the posterior and inferior temporal cortex, PIT or AIT. Okay, it means it is moving through variety of layers. So, which contains the neurons and respond specifically to certain objects. The inferior temporal cortex projects a variety of areas, including the prefrontal cortex, PFC, which contains the visually responsive neurons that categorizes object, PFC. Okay. Then number one, to reach the muscles in the hand signals, to reach the muscles in the hand signals, probably need to pass via the premotor cortex, PMC, and primary motor cortex, MC, before reaching the motor neurons to the spinal. And it means it is simply describing the internal structure of the brain. All the regions are having some functions. So this is basically functional representation of the monkey brain. So each processing stage, for each processing stage, two numbers. This is the lower and higher numbers, means in between this much time is required. Okay, so here you can observe that this is LGN, and here simple visual forms like edges or corners are detected in this area of the brain. Got it? And then it passes to V4, and V means this is another feature, and then higher level abstraction. So here intermediate visual forms like feature groups, etc., means group of edges, group of corners, etc. These kind of objects will be formed in this area. And then this in AIT, high level object descriptions, face objects, etc., will be generated in this area. And then this PFC, so categorical judgment decision making on the basis of high level features. And then motor commands are released from this area of the brain, and it goes to the spinal cord. It means it is passing through different areas of the brain, and every area of the brain is having some specific function, but signal passes from the area which is generating the lowest level of feature to mid level of feature to high level of feature to highest level of feature, then motor commands are released. Okay, exactly the deep learning models also used to do this thing. So that's why we used to say that deep learning models are basically brain inspired architectures, because in brain hierarchy of feature is being generated. That's why in these kind of machines the hierarchy of features must be generated, then only these models will be simply known as the deep learning models. So probably it is clear, some motivation. Okay, now I can move very quickly. So state of the art in vision, like ImageNet challenge. So what was there? Mostly the research in deep learning started in 2012 afterwards. So AlexNet came into 2012. The error rate was quite high, 16.4%. Then next year, Taylor-Fergus net, its error was 11.7. Then VGNet 7.3%, GoogleNet 6.7%, then ResNet in 15. Then ResNet, GoogleNet, inception 4, here 3.6, 3.06, and then CNet 2.25. And after that, even after that, large number of networks have already been reported. So these are the state of the art networks. And what is happening? The level of accuracy is improving, means level of error is decreasing. So normally after this, means after 2014, for this ImageNet data set, that is simply known as the Computer Vision World Cup, basically. So earlier, humans were winning this Computer Vision World Cup before 2014. But after 2014, machines started winning the ImageNet World Cup, Computer Vision World Cup. So machines basically outperformed the humans, basically for this particular task. So what was the task? There were lakhs of the images of multiple, means variety of objects, and machines were more capable of learning that which image is for which kind of object, where humans actually failed. Okay, so for this particular task. Similarly, vision, these architectures can be used for the detection or segmentation. Like there is a complex scene here, large number of people are sitting. Okay, then is it possible to detect each and every object? Yes. If it is possible to detect each and every object, then is it possible to segment them? Which area belongs to which particular object? Yes, it is also possible. That is simply known as the segmentation. So detection, segmentation. Is it possible to create a story? What is happening in the scene? Okay. For example, I have installed the camera in my drawing room or my study room. Okay. Then on my mobile, is it possible to get the alerts what is happening in my study room? Yes. Nowadays it's possible to design such algorithms with the help of deep learning. Yes. It will simply analyze, find out the objects and how those objects are being arranged. And on that basis, image to text will be generated that can be transmitted to your mobile. So you can get everything what is happening. So these are typical vision applications. So mask RCNN. So basically object detection, RCNN, fast RCNN, faster RCNN, and many advanced architectures are coming every year. This is typical image generation. Here you can, many deep learning architectures have been reported, like in ICLR 2018. Generative adversarial network based model have been proposed, where realistic faces are being generated. Like these kind of faces are being generated, which were actually never in the data set. You know, some sort of faces are being generated which are actually no such person is existing. For example, even then the faces can be generated for these persons. Okay, so now GAN field is quite mature, and these generative adversarial networks are having large number of applications. So whenever there is a need to synthesize the data, means synthesis is required. In that case, you can use a generative adversarial network. Means whatever probability density function is required to be generated, that probability density function can be generated with the help of GANs. Here, in this image generation task, okay, so synthesize ImageNet images conditioned on class level up to 512 by 512, quite large, I mean, big images can also be generated. So actually these images were not the part of the ImageNet data. Still, these kind of images have been generated by the GANs. These images were never captured. Actually, never, I mean, there was no such scene. Even then, these have been generated. And that was demonstrated in ICLR 2019. This is a Tier 1 conference in the domain. International Conference on Learning Representation. But there are some difficult classes also, means some distorted images were generated in this case. But yes, recently, I mean, many other architectures have been reported which have resolved these kind of issues. Similarly, in Vision, you can find out Facebook as accessibility tool for visually impaired. Okay, so your camera can work as eyes for you just because of the development of the deep learning in the domain. Similarly, this is an example, AI beats human pathologists at detecting the cancers. So nowadays, I mean, in India, it is not, I mean, we are not taking the help of computers for this purpose. But very recently, I visited one of the medical college in Germany. This is, I mean, this medical college is collaborating with the university. So those people are really developing these models, means how this AI, in modern AI, can help for the mankind or for the humanity. So yes, AI beats human pathologists at detecting the cancer. It means now AIs are better in picking the pixels, means digitized images. In the digitized images, the pixels which are actually cancerous in nature. Okay, and technology behind Snapchat lenses for many luxury and many fun kind of applications, it is possible. So these kind of applications are for the development of the technology for the humanity, and these kind of applications are for technology for fun or something for luxury or convenience, what you can say. Sometimes vision working too well, although it is unethical in case of, I mean, facial recognition systems are being installed at various places in China just to take a stock or just to have a watch on some people. Like there was a report how China uses high-tech surveillance to subdue minorities. Although it is unethical nature, but yes, they are using. In India, we are not using these kind of things. It means the camera is installed somewhere. If somebody is passing by that camera, immediately the information which is tagged with that face will come side by side. Means who is the person, what may be the intent. So prior information is available, okay, and appropriate preventive or whatever kind of actions are required maybe to. Similarly, here a person was punished just because of the wrong face recognition. He was not the actual person, but yes, the machines predicted no, he is the culprit, and somehow he was punished. But later on during the trials, it was, I mean, the person was disclosed as basically, what do you say, innocent. So wrongfully accused by an algorithm. So these are the problems with the algorithms. Yes, but people are simply improving the performance by the experiences. Here, this is another thing. This is a big threat. Now earlier people talk about the security of the content or network security or something, but this is another new dimension where we will be bound to work. Bound to work means, say I'm speaking something in the public, okay, then these machines can generate my speech without my presence for the speech which I never gave in the public. It means complete havoc can be created. In a movie, complete person can be changed. It means entirely the content of the image or content of the videos can be completely changed or morphed or modified as per our requirement. So that's why there is a huge, I mean, in coming 5 to 10 years, this will be the this is going to be the biggest problem for any country. Okay, like Prime Minister never spoke anything about something, but in newspapers or news channels it may come, okay, Prime Minister told this or told this or told this. So, but yes, we need to think. Okay, people are doing this thing. So if technology is developing for the betterment, so this is a flip side of the technology, that these kind of problems will arise in the future, and we have to be ready for these kind of scenarios. So simple morphing and other things. Okay, so this is typical example, vision working too well, deepfakes. So deepfakes concept is there. It was introduced in 2018. So this is the input. The person's face was the input, and somehow these were the outputs. Means a lady produced these kind of expressions. Okay, these kind of expressions were produced by the lady. So somehow means these expressions can be transferred on this face. So here you can find out how the expressions can be transferred. Got it? So basically, say vice versa, these were the required expressions. Okay, these are generated on those faces, and in realistic scene, you can find that the similar kind of expression can be generated on different persons. Okay. So basically, not only the scene, the expression, okay, the action, and everything can be morphed now in the most realistic manner. So you may be punished for the act which you never did actually. So these are the flip side of the machines development. Similarly, these machines are very well used in case of natural language processing. Initially in 1950s, Turing test was introduced. So most of you must be knowing about it. If you don't know, please go through the Turing test. I'm not going to talk about this thing. I'm moving very quickly now. So machine translation concept came in 1954. Okay, in 1966, Automatic Language Processing Advisory Committee suggested something for the machine translation, and they recommended something. Then ELIZA was the first chatbot introduced in 1966, simulated as a psychotherapist could fool naive users. So basically, it was possible to fool the users, whether a person is writing or a chatbot is writing, basically. So similarly, the state of the art in speech and language, what happens earlier in case of speech and language, the performance was improving, means rate of error was decreasing. But 2000 to 2010, it got saturated. There was no significant development in this dimension. But with the advent of the deep learning, suddenly what happened? The level of error decreased too much, and we are living in the era of the error of 0.1, 0.2%. So the level of accuracy is 99.9 or 99.8. We are living in that era. How? Just because of the development of the deep learning. So several big improvements in recent years in natural language processing, like machine translation, sentiment analysis, dialogue agents, question answering, test classification, etc. So success in natural language processing. So neural machine translation. So the great AI awakening, like Google Translator, what is happening? You write in English, it gives in Hindi, or vice versa, or in any other language. But it's improving. The performance is improving day by day. If you observe that earlier how this Google Translator was working, so what is happening? We are using the Google Translator, putting some data. If it is not correct, then we are correcting also. Got it? So basically, we are annotating the data, and this data is being deposited in the repository, which is actually used to improve the performance. So this way, we are creating the experiences actually to be used by the backend machine to improve its performance. So in games 1952 to 59, Arthur Samuel programmed a digital computer to learn to play checkers. Okay. In 1960, Donald Michie built a machine out of 304 matchboxes that could learn to play tic-tac-toe. Okay. So these kind of automation or something, some rule-based things were designed. In 1959, I mean the same thing, but what Donald Michie description of reinforcement learning comes from 1961 and is the first use to term reinforcement learning when applied to machine process. It means the concept of reinforcement learning came into the picture and people started designing the machines, I mean games. So in 2013, DeepMind uses deep reinforcement learning to beat humans at some Atari games they developed. In 2016, DeepMind's AlphaGo system beats Go Grandmaster Lee Sedol and his career was completely abolished. So in 2016 onwards, your machines has taken over the human brains, even in case of the games where a lot of strategies are required. Okay, so 2017, AlphaZero learned to play Go and chess from scratch. It means it is not required to program or something. You simply give the chess and they will learn how to play the best chess or best AlphaGo. It means there is no need to even train them. The training will happen itself. They will learn from scratch. Okay, so these kind of developments are going on. In 2019, DeepMind's StarCraft 2 AI is better than 99.8% of all human players. So this is the state of the art in case of games. So games, if we talk about the games, games give the exact picture of the human capability where the perception is important, attention is important, strategy is important, memory is important. So almost every area of the brain is important while you play some game. Okay, especially these kind of games. So that's why how effectively machines are simply beating the complete human brains. In case of robotics, I mean, variety of robots are being designed. Earlier, these were very simple, pick and drop kind of simple. Now, very complex robotic systems are being designed. Okay, so vision and robotics are quite, quite important and quite correlated. So robots without vision are simply said that human without eyes. Okay, so eyes are the best sensor. That's why now people are able to design the best kind of robots. So various platforms are possible for robotics like simulation, AI to Thor, Habitat. Real robots, Pi robots can be used, robot on your smartphone. So open bots can be used. Simply, you can program your mobile itself can work as a bot. Okay, you simply install an interface variety of sensor and that can be used. Okay. So these are some interesting issues. Self-driving cars are now based on the deep learning models. Okay, so deep learning crucial for global success of automotive autonomy. So this was reported in 18 itself. Now sophisticated models are being designed. So this was the development of deep learning, and this is simple. I mean, chronological development like machine learning. Initially, the linear classifier, then multi-layer neural network, backpropagation, etc. Then CNNs came into the picture. After that, network for detection or segmentation. Then network for dense prediction. Okay, means somehow to synthesize something, it was possible. And then generative adversarial networks came into the picture. Then recurrent models for sequence analysis or something. And then we are living in the era of transformers basically and deep reinforcement learning. So nowadays, a lot of people started working on transformers and deep reinforcement learning. Actually, just to have better and better performance for most and most complex applications. So, Dr. Varun?
Yes, sir.
How much time I have?
Sir, it's 2:30, but you could take 5-10 odd minutes.
Yes, okay. So now very quickly I will introduce a variety of deep learning architectures. Like we talk about the convolutional network, it's a neural network. So basically, in case of the convolutional neural network, the concept of local connectivity, weight sharing, okay, these two concepts enable the convolutional neural network to reduce the level of complexity while preserving the nature of the hierarchical representation of the features. Okay, so that's why it was acceptable by all. Means level of complexity means number of required parameters were actually optimized, and these were able to handle multiple input channels and handling multiple output maps. So multiple input can be given together while having the multiple outputs for any application. So typical examples were the AlexNet, the VGGNet, the GoogleNet, ResNet, DenseNet, RCNN, faster RCNN, YOLO SSD, etc. These are typical convolutional neural network based models. So what are typical application of CNNs? So image classification, object categorization, face recognition, biometric recognition, biomedical image recognition, etc. All those. Object detection, face detection, pedestrian detection, human detection, etc. These are other object detection kind of applications. So classification and detection, both kind of architectures can be used for a variety of applications. Another network was the autoencoder network, where what was there? We were having the layers with high dimension, and then gradually the dimension was reduced. And if we talk about this level at this point, then the dimension is quite compact. It means some sort of compression is happening. And then we are doing decompression and producing the result. So say this is scene where we need to identify the crack area, suppose, okay. Then with these kind of data, means this is annotated data, and we can train the network. And if any unknown crack is coming, simply give to the input and that will be highlighted. So this is a kind of image synthesis, some sort of unit U structure is there. So some sort of unit architectures are actually designed for these kind of applications. This is simple autoencoder and decoder framework. This is encoder, this is decoder. So an autoencoder learns the feature representation such that latent space from unlabeled data or unsupervised learning, and it contains two networks, encoder and decoder. So what are the examples? Fully convolutional network, deconnets, signet, unit, mask RCNN, etc. use the concept of autoencoder decoder. One of PhD with me also did in the case of image compression, where we exploited and we have designed some new or novel architectures based on top of these concepts. So autoencoder networks applications involve like semantic segmentation, medical image segmentation, dense prediction, depth map prediction, image retrieval, image to image translation, image enhancement. These are typical application of autoencoder. So here we talk about the image. Image is two-dimensional data. You can talk about the signal. Signal is basically one-dimensional data. It means if it is image to image translation, okay, means one image can be translated into another image. So is it possible to generate one speech to another? Means is it possible to generate Varun's speech, I mean Varun's way of talking from my way of talking? Whatever I have discussed, I have spoken, is it possible to convert as it would have been spoken by Varun? Yes, it is possible. So that's why these architectures are useful. Then generative adversarial networks, GANs. So there is a concept of generator and discriminator. So basically this is there is very interesting story behind this. So Ian Goodfellow was sitting with his colleagues, his students, actually in a bar. They were drinking, and in the night they started some adversary. It means if I say yes, you say no. I say yes, you say no. These kind of arguments, counter arguments started for resolving some issue, and they were able to resolve the issue with the help of only these yes and no. And suddenly the concept came in his mind, and in the night itself they coded and they came up with a wonderful concept of generative adversarial networks. Nowadays, this is the most widely used concept or most widely used networks, and a lot of newer and newer generative adversarial models on top of traditional GANs have been developed. One of my PhD is also doing for sketch to image synthesis, okay, from thermal to visual image synthesis, and we have reported very recently in IEEE transaction. So people are working in these domains. So these are typical applications like sample generation, image to image translation, text to image translation, face post frontalization, face aging generation, image deraining, image haze removal or dehazing, image imprinting, image super resolution. All those can be, means all the image can be changed with the signal. Simply change the image with the signal and you can do this thing. Got it? Like here, there is a raining and some football match or something is happening. Similarly, you can have the signal. If you transmit the signal in rainy environment, what happens? Some noise is picked up. So you might have experienced in earlier televisions where we were using the Yagi-Uda antenna, okay, and this transmission was quite disturbed while there was raining outside, isn't it? So if at that time these kind of models were available, then it was possible to minimize the effect of raining, okay, before the display in our TVs. So nowadays it's possible, isn't it? Means whether it is one-dimensional, two-dimensional, or n-dimensional signal, these kind of things can be done with the help of generative adversarial networks. And then these are the recurrent neural networks, are RNNs. So normally, whenever there is a requirement to analyze the data which is sequential in nature, means temporal, whenever temporal information is useful, in that case, you need to use the recurrent neural network. Now people started talking about the LSTM, bi-LSTM, even vision transformers and others. So these are taking care of these sequential data. And many variants are possible. Like there is a single image, suppose, or single input, so multiple outputs can be generated. Multiple outputs to single output is possible. Multiple input to multiple output. So this is typical example of language translation. We have given this sequence in English and this sequence is Hindi. Got it? Similarly, here also it is possible. Means this can be used for the translation. So variant of neural networks to incorporate the temporal information. Basically, the main and most important feature of recurrent neural networks, RNNs, is hidden state, which remembers some information about the sequence. So RNN variants are long short-term memory, means concept of LSTM and GRUs are gated recurrent units are basically used to come up with the final application specific architectures. So these are typical application of RNNs, like sentiment classification or analysis. So goal is to classify a text sentence such that restaurant, movie, or product review, tweets, etc. as having positive or negative sentiment. Text generation, what is the goal? Sample from distribution of a given text corpus, also known as language modeling. Okay. Then image caption generation means text generation and caption generation. So goal of caption generation is to generate a short description of the images in the caption form. Machine translation goal is translate the text like word, sentence, paragraph from one language to another language. So these kind of applications. But in case of language, now people replaced those words with the images, okay, or some videos. So people started designing some vision-based LSTMs, you can say. So basically, input is now image rather than text, and variety of things can be done. So video can be generated, video can be analyzed, one video can be transformed into another video. So this is possible. So here, I mean, just so this is just Varun, is it
ever wondered how Google
Yes, sir.
then
Yes, sir.
type your web page to a different language in a matter of seconds, or your phone gallery groups images based on their location. All of this is a product of deep learning. But what exactly is deep learning? Deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence. Artificial intelligence is a technique that enables a machine to mimic human behavior. Machine learning is a technique to achieve AI through algorithms trained with data. And finally, deep learning is a type of machine learning inspired by the structure of the human brain. In terms of deep learning, this structure is called an artificial neural network. Let's understand deep learning better and how it's different from machine learning. Say we create a machine that could differentiate between tomatoes and cherries. If done using machine learning, we'd have to tell the machine the features based on which the two can be differentiated. These features could be the size and the type of stem on them. With deep learning, on the other hand, the features are picked out by the neural network without human intervention. Of course, that kind of independence comes at the cost of having a much higher volume of data to train our machine. Now, let's dive into the working of neural networks. Here, we have 3 students. Each of them write down the digit 9 on a piece of paper. Notably, they don't all write it identically. The human brain can easily recognize the digits. But what if a computer had to recognize them? That's where deep learning comes in. Here's a neural network trained to identify handwritten digits. Each number is present as an image of 28 times 28 pixels. Now, that amounts to a total of 784 pixels. Neurons, the core entity of a neural network, is where the information processing takes place. Each of the 784 pixels is fed to a neuron in the first layer of our neural network. This forms the input layer. On the other end, we have the output layer with each neuron representing a digit with the hidden layers existing between them. The information is transferred from one layer to another over connecting channels. Each of these has a value attached to it, and hence is called a weighted channel. All neurons have a unique number associated with it called bias. This bias is added to the weighted sum of inputs reaching the neuron, which is then applied to a function known as the activation function. The result of the activation function determines if the neuron gets activated. Every activated neuron passes on information to the following layers. This continues up till the second last layer. The one neuron activated in the output layer corresponds to the input digit. The weights and bias are continuously adjusted to produce a well-trained network. So, where is deep learning applied? In customer support. When most people converse with customer support agents, the conversation seems so real. They don't even realize that it's actually a bot on the other side. In medical care, neural networks detect cancer cells and analyze MRI images to give detailed results. Self-driving cars. What seemed like science fiction is now a reality. Apple, Tesla, and Nissan are only a few of the companies working on self-driving cars. So, deep learning has a vast scope, but it too faces some limitations. The first, as we discussed earlier, is data. While deep learning is the most efficient way to deal with unstructured data, a neural network requires a massive volume of data to train. Let's assume we always have access to the necessary amount of data. Processing this is not within the capability of every machine. And that brings us to our second limitation, computational power. Training a neural network requires graphical processing units, which have thousands of cores as compared to CPUs. And GPUs are, of course, more expensive. And finally, we come down to training time. Deep neural networks take hours or even months to train. The time increases with the amount of data and number of layers in the network. So here's a short quiz for you. Arrange the following statements in order to describe the working of a neural network. A, the bias.
So with these things, I'm just closing the discussion of the day. So here there is another slide regarding this shallow and deep models. So many models, shallow models and deep models have been proposed, like decision tree GMM, sparse coding, RBM, SVM, all those are the example of the shallow models where this DBN, DBM, DAE, ConNet, RNN, neural nets, all are the examples of the deep neural networks. So out of these, there are some probabilistic shallow model, probabilistic deep model, probabilistic, you can say, a neural network shallow model, neural network deep models. So you can classify in this way. So these are some hybrid models basically. So if we talk about the DBN and DBMs, so basically these are the examples of the deep models. Okay, so these are probabilistic as well as neural networks. Both concepts are there. So concept of probability has been included into the neural network. So probabilistic neural network. So DBN and DBM are the probabilistic neural network, and now people are working on probabilistic graphical models as well. So these are the example of supervised and maybe unsupervised as well. So this way, people are developing variety of models for variety of applications. So I think this is just an introduction about the deep learning, its development, the concept behind it, how it's related to the human learning, what are the possible application, what is the development where we are moving in the domain of deep learning, what is the threat while using the deep learning, okay, what are the problems which we are going to face in the future, and how we should be prepared just to combat the problems which may arise with the advent of the deep learning. With this discussion, I'm just closing the session. So thank you very much. Now, if you have any doubt, then we can discuss or we can stop the discussion.
Thank you so much, sir, for this insightful keynote address. I'm still in awe of the strategy you applied to make us learn on deep learning. So well articulated, sir. Grateful for your time and benign presence. So participants, like if you have any questions, so session is open for you. So come forward for the questions or any query.
Sir, I'd like to ask, as you earlier talked about overlearning, the problem of overlearning in machine learning algorithms. So what procedure or what methods do people use to prevent or protect the algorithms from overlearning?
Normally what happens, if there is a chance of overlearning, so you try to do some sort of generalization. Okay, means generalization, you can consider that learning with the noisy data. Actually, you introduce some sort of noise. Got it? If you introduce some sort of noise in the learning process itself, then these kind of, this is very abstract concept. It is difficult to understand. Okay, but you can consider some regularization techniques and other things can be used, like in case of a decision tree, why pruning operations takes place, why connect or drop out layers are used in case of the convolutional neural network or traditional neural networks as well. Means in case of machine learning, means whether it is traditional machine learning or the deep learning, everywhere the concept of regularization have been introduced. Okay. Somehow it's related to the bias and variance. So how well we are able to optimize this bias and variance, basically. So entire machine learning and deep learning revolves around only and only bias and variance. Okay. So yes, standard techniques are there. Yeah. Basically, I used to discuss these techniques, how to improve the performance of deep learning model in my class. So there are standard practices. So if you find time, then please go through these things.
Thank you, Yatharth, for your question. Anyone else, like if you have any other query?
Yes, ma'am.
Okay. Yes, Nikunj.
Sir, I want to ask that you said that the machines have play more accurately than humans. So there will be a time that machines can surpass human intelligence.
Yes, it may come. Basically, I was talking, I have taken the development from 2012 till date. 2020 you can say that after 2014, machines started behaving better than the humans. But what was the task? The task was the image classification, okay, for ImageNet data. Although there were lakhs of the images, but if you include crores of the images or crores of the images, then again you need to improve the performance of the machine. So obviously, for some particular tasks, machines are becoming better than humans. But in general, humans are having enormous capabilities. Like if you want to design a machine learning model for image classification, this is a single model. This is a single model. But your brain can do the classification, your brain can do the recognition, even speech recognition, image recognition, video recognition, classification, detection, everything can be done with the help of the human brains. So human brains are having n number of capabilities. Where is this n is tending towards infinity? How? Because of the generalizability of the human brains. How it has been achieved? With the help, with the experience itself. Okay, so if you want to design a machine which is exactly matching the humans in all the dimension, at least same amount of time is required to train this machine as humans take throughout the life, maybe 40 years. But yes, it's possible. So good to know that these questions are there. At the same time, I just want to advertise, do some sort of advertisement for my group. So basically, we are very open for the PhD students. If some of you are masters or some faculty members in some institutions, etc., then we can work together if somebody is interested, even in internship and other things also. Okay. So basically, there is a provision here at IIIT Allahabad as a PhD for working professionals. So if some person is doing some job in some research laboratory and other places, so immediately those will be inducted and their own research places can be treated as the extended research laboratory of IIIT Allahabad. So normally the residential requirement is waived, provided you meet your supervisor 15 days in a semester, maybe Saturday, Sunday, and many. These way. So many things we are open for PhD. So if somebody is interested, or if you can recommend somebody, they're most welcome. But yes, they have to pass, they have to move through the process, admission process.
All right. So noted down this, sir, like if students are in need of this, like we will definitely share this information. So, all right. So Varun sir, like, shall we move ahead with the technical session now?
Yes. So
right.
Thank you once again, sir, for giving your precious time.
Thank you, Varun. Thank you, Varun, for inviting us. Inviting me exactly, not us. Thanks a lot, Madam Garima, for handling this session very well. And thanks to all the participants who are here just to discuss something. Thank you.
Thanks a lot.
So with your permission, I am leaving now.
Yes, sir, obviously.
Also. Okay. So hope like you people learned a lot out of this last session of the keynote. Now is the time to move ahead with the second technical session of the day. So all the participants are advised to stay tuned as your technical session will take place now. So wishing you all the most and more from this conference. Now this session will be chaired by Dr. Ramnaresh Sir, Professor and ex-head Department of Mathematics, Harcourt Butler Technological Institute, Kanpur. He has earned his doctorate from IIT Kanpur in 1993 in mathematical modeling air pollution after qualifying CSIR, JRF and SRF examination. That was a big deal. So he widely has published in international journals, peer reviewer of various international journals. Like he has also attended various conferences and refresher courses, won many prizes for Best Paper Award and Best Educationist as well. Also delivered many invited expert lectures on environmental systems and mathematical modeling. He also peer reviews journals, to name a few: Applied Mathematical Modeling Elsevier, World Journal of Modeling and Simulation, World Academic Union, International Journal of Applied Mathematics and Computation, Differential Equations and Dynamical Systems, Springer, etc. He is joint editor of the book Mathematical Analysis and Applications, published by Narosa Publishing House, New Delhi. His research interest lies in mathematical modeling of environmental and ecological systems, mathematical epidemiology, transmission dynamics of HIV and AIDS, nonlinear dynamics, etc. So I request Dr. Rajan Kumar Sharma, Sir, PSIT, to accompany Professor Ramnaresh, Sir, for chairing this session ahead. Thank you, sir. So Dr. Rajan Kumar Sharma, sir.
Thank you, ma'am. I welcome to this International Conference of Computational Mathematics and Engineering, ICCMEA 2022, under IST, Indian Society for Technical Education, and IEEE UP section. I heartily welcome to Dr. Ramnaresh Tripathi, sir. It's my great pleasure that we are modeling things we can learn today, the basic concept and some wonderful and special things of the mathematical modeling with our Professor Dr. Tripathi, sir. It's my great pleasure. So I think that Professor Ramnaresh Tripathi, sir, please, sir, you guide us for this session. Thank you.
Yeah, I'm here. Thank you, Rajan. Thank you, Dr. Garima Williams ji. You have very nicely spoken about me.
Pleasure being all mine, sir.
I express my thankfulness to all the organizers for giving me this opportunity to chair this technical session of the conference on International Conference on Computational Mathematics and Engineering Applications. Actually, I just joined at 2:25. So there was a keynote address going on by Professor Satish Kumar Singh. I really enjoyed this keynote address. It was very nicely delivered, and a lot of components regarding cryptography, deep learning, and machine learning, image processing, etc. were included. And why I got interested in this one, because we in our department started a master's program in mathematics and data science. So we used to guide our students regarding all these things, machine learning and other components of data science and cryptography, etc. So I enjoyed a lot, and I thank Professor Satish Kumar Singh for this such a nice lecture as well. So I also thank the organizers, and I think now it's a little late, so we start with the technical session number 3. And Dr. Rajan, shall we start with the technical session now?
Yes, sir. So today the first participant is paper ID 35, Priya Verma, Maninder Singh Arora, and JB Sukla, sir. So participants are ready. Priya Verma, ma'am, are you available?
Yes, sir.
Okay, ma'am. So you proceed your paper.
Okay.
Priya Verma, your topic of presentation is reducing the impact of heat waves.
Reducing the impact of heat waves of human population through a new vegetations, a mathematical modeling study.
I would like to just state to the presenters that the time slot is little, short, so you need to complete your presentation within 10 minutes, I suppose, for each right? Okay, Priya, you start with your presentation.
Okay, sir. Good afternoon to one and all present over here. I am Priya Verma, research scholar, doing PhD under the supervision of Dr. Maninder Singh Arora, sir. I am going to present the paper on the topic reducing the impact of heat waves on human population through avenue vegetation, a mathematical modeling study. Dr. Maninder Singh Arora, sir, and JV Sukla, sir, also have helped to complete this paper. These are the content of my paper: introduction, mathematical model, equilibrium analysis, stability analysis, numerical simulation, conclusion, and last references. In the introduction part, we define heat waves, global warming, greenhouse gases, and avenue vegetation. So heat waves are long-lasting, extremely hot waves during the summer season. A heat wave is an exceptionally high temperature phenomena that affects human health, agriculture, work efficiency, productivity, frequency, and intensity of wildfires, public infrastructure, livestock, fisheries, transportation, environment, etc. People affected by the heat wave include young children, the elderly people, people working in hot conditions outside the home, residents of urban areas, and pregnant women. The people living in extremely hot climate, cases of dehydration, exhaustion, fatal heat stroke, kidney problems, lethargy and death, poor mental health status, increased incidence of cardiovascular and respiratory disease, cardiac arrest, poor work performance at workplace, etc. are reported regularly. Over 65,000 call for hospitalization every year. Global warming. It is the long-term warming of the planet overall temperature. It occurs when carbon dioxide and other air pollutants and greenhouse gases collect in the atmosphere and absorb sunlight and solar radiation that deflect on the Earth's surface. It is primarily due to the greenhouse gases released by people burning fossil fuels and other human activities. It is affecting ice melting at poles, sea level rise, floods, droughts, and intense rainfall. Greenhouse gases. A greenhouse gas is a gas that absorbs and emits radiant energy within the thermal infrared range. These gases are trap the heat in the Earth's atmosphere. The most prominent greenhouse gases are carbon dioxide, nitrous oxide, methane, and water vapor. Avenue vegetation. Large shrubs planted climbing vines with plus and planted same species can be used as avenue vegetation. For shading buildings, boundaries, strategic locations around industrial areas, parking lots planted along the roadsides, highways, and footpaths. Avenue trees absorb carbon dioxide from the atmosphere and keep the area cool. Oxygen generate all shrubs, vines, and trees can assist to decrease the rippling effect of heat waves. With the help of avenue vegetation, reduced reduced. This is the mathematical model of my paper. The dynamics of the system are governed by the following nonlinear ordinary differential equation. In these equations, the variables are N be the density of human population, C be the concentration of carbon dioxide into the atmosphere, T be the atmospheric temperature, and V be the avenue vegetation density. These are the parameters name of my paper. Region of attraction. The model equation 1 to 4, the region of attraction of R variables is represented by omega. Equilibrium analysis. Here only 3 positive equilibrium points have been derived from the model equations, which are lie in the region of attraction. So in first equilibrium points, we consider human population is 0 and carbon dioxide and atmospheric temperature remains its initial level. So this equilibrium will be always feasible. In second equilibrium, avenue vegetation is 0. So all points belongs to inside the region of attraction. In third equilibrium or non-trivial equilibria, check feasibility of this equilibrium at boundary points C0 and Cm. So this equilibrium will be feasible if it satisfies the B1 condition. Stability analysis. Stability analysis of the equilibrium points by checked by the Jacobian matrix and Lyapunov method. First equilibrium, we determine the Jacobian matrix. So after determine the eigenvalues of Jacobian matrix J1, we find two eigenvalues which have positive sign, which is R minus R0 and S minus S0 plus S12 C. So this equilibrium will be unstable along NV plane and stable along CT plane. After determine the eigenvalues of a Jacobian matrix J2. Here one eigenvalue have positive sign, which is S minus S naught plus S12 C bar. Hence, this equilibrium will be unstable manifold along B direction. To find the stability condition of third equilibrium by Lyapunov method. Theorem first, the equilibrium point E3 will be locally stable if it is satisfy the P1 condition, and theorem 2, equilibrium will be globally stable if it is satisfy the condition S1. These are the parameters, values, and units of the model. These are the numerical values of equilibrium points and eigenvalues which have been derived by substituting the above values of parameters in model equations and variational matrix. Feasibility of the model also checked by the graphs. This graph shows that the global stability of the model. It is seen that the solution curves corresponding to different initial conditions falling within the region of attraction converge to the interior equilibrium. Figure 1 and figure 2 show that when intrinsic growth rate of avenue vegetation and carrying capacity of avenue vegetation have been increased, then human population also increases. And figure 3 and figure 4 show that when intrinsic growth rate and carrying capacity of avenue vegetation have been increased, then intensity of heat waves can be controlled. Figure 5 and figure 6 show that when the absorption rate of carbon dioxide is increased by avenue vegetation, the human population increases and intensity of heat wave decreases. Conclusion. Environmental temperature cannot be controlled without reducing carbon dioxide emissions. Due to human activities, the amount of carbon dioxide in the atmosphere is increasing rapidly, due to which the incidence of heat waves is also increasing. This increase in carbon dioxide has contributed to massive increase in respiratory illness, increased heart rate, asphyxia, and convulsion in humans, and has contributed to the shortage of clean, fresh air. Model analysis shows that an increase in the amount of avenue trees and the rate at which carbon dioxide is absorbed by them leads to an increase in human density and a decrease in heat waves. Therefore, optimal use of avenue trees can serve as an effective tool to control the heat waves and its effect on mankind. These are some references which we have used to the study. Thank you.
Thank you, ma'am. The participant ask you any questions? Any question towards participant side? Then you may ask. No question?
Well,
yes.
Priya ji.
Ji, sir.
You have presented a very good model, and I think I have also seen this earlier also while during the presentation at CSJM University. You remember, you someday before there was a RDC meeting, you presented the same model.
Yes, sir.
Right?
Yes, sir.
Okay, your model is very good, of course. And did you check the equilibrium points that you have given? Are they actually 3 or more equilibrium points are there? You need to recheck it again, whether only 3 equilibrium points exist or more equilibrium points are possible. You just check this point.
Yes, sir. Sir, one another equilibrium point have been determined, but this equilibrium point have outside the region of attraction. So this is neglected.
I'm not questioning that. I'm simply saying that you make sure that all the equilibrium points which are possible have been taken into account. Right?
Okay, sir. Okay.
And, one more point is there. You are talking about the reducing the impact of heat waves on human population through avenue vegetation. So for this, you need to also do optimal control analysis. Did you do that?
No, sir.
Not yet. Okay. You also explored this point, whether the optimal control analysis can be done on because at 2-3 places you have used that optimal word. So actually for that optimal control analysis is to be done, because then only this avenue vegetation can be optimally used. Thank you very much. You have very good presentation.
Thank you, sir.
Thank you, ma'am. Thank you, sir.
We call the next candidate.
Yes, the next presentation will be for paper ID 37. The participant is Ahana Verma, JB Sukla sir, Maninder Singh Arora. The topic is mathematical modeling and analysis of effect of awareness program in conservation of water resources. So participant is ready?
Yes, sir.
Okay, so proceed, please.
Rajan?
Yes, sir. Yes, sir.
Just call the name of the presenter only, instead of reading all the names in the paper.
Okay.
Good afternoon, everyone. I am Ahana Verma, doing PhD, Department of Mathematics, PG College, Kanpur. The title of my paper is Mathematical Modeling and Analysis of the Effect of Awareness Program on the Conservation of Water Resources. The outlines of my paper is Introduction, Mathematical Model, Equilibrium Analysis, Stability Analysis, Numerical Simulation, Conclusion, and References. Introduction. The study of the conservation of water resources is very important to be done both logically as well as experimentally. 71% of Earth's surface is covered by water. Usable. Since last few decades, the demand of fresh water has increased, which is putting more pressure on Earth's resources and ecosystem. Management of water resources is a critical issue around the world with increasing population and water consumption. In order to make the population aware and educate, our focus will be on the education system and awareness programs such as TV ads, radio, stage performance, and online platforms, etc. Awareness programs may be helpful to change the public attitude and behavior of the population towards the water wasting, and other than this to maintain the quality of water resources. Mathematical model. To keep this in mind, we formulate a non-linear mathematical model by using ordinary differential equations, considering different equations for water resources, total unobserved population, observed population, and awareness program. The first equation of the model, dw upon dt is equal to q minus k beta naught w minus k beta w nu minus k beta 1 w na, where w is the density of water resources, q is the constant rate of fresh water, beta naught is the natural depletion of water, beta is the depletion of water due to unobserved population, beta 1 is the depletion of water due to observed population, and the second equation of the model dnu upon dt is equal to r nu 1 minus k nu upon k minus k r naught nu plus k r1 nu w minus k r2 m upon t plus m nu, where nu is the density of unobserved population, r is the intrinsic growth rate of unobserved population, k is the carrying capacity of the unobserved population, r0 is the natural death rate of unobserved population, r1 is the growth rate of unobserved population, r2 is the spread rate of awareness among the unobserved population, due to which they form a new observed class. T is the hub saturation point. Third equation of the model, dna upon dt is equal to r2 m upon t plus m nu minus k r2 0 na plus k r2 1 nu w, where na is the density of observed population, r2 is the same, and r2 0 is the natural death rate of observed population, r2 1 is the growth rate of observed population due to water. And the last equation of the model, dm upon dt is equal to mu nu minus k mu naught m, where mu is the implementation rate of the awareness program and mu naught is the depletion rate of awareness program. Boundedness of the system. To study the boundedness of the system, Around the different steady state, we find the boundedness of the system is the given following set. Equilibrium analysis. In this section, first we determine the equilibrium by setting the rate of change of variables equal to 0. Then the model has only two non-negative equilibrium points. E0 is the trivial equilibrium point and E star is the unique non-trivial equilibrium point. When we obtain the equilibrium point, then we analyze the stability of the model locally and globally by the theorem first and theorem 2. In theorem 2, the non-trivial equilibrium E star is globally asymptotically stable provided that there are two inequalities hold. In theorem 2, the non-trivial equilibrium E star is globally asymptotically stable provided that there are 5 inequalities are hold. Numerical simulation. To justify the analytical finding of the model numeric by considering the following set of parameters. Various conditions are obtained in equilibrium analysis and stability analysis are satisfied by these parameters. Model is solved numerically by using MATLAB. To justify the graph, analytical finding and graph are plotted to study the variation of important variables and the system with the time and different parameters. In figure 1 shows the global stability of the equilibrium. It is observed that from figure 1, the solution trajectory of the model is starting at any point within the region of attraction approaches the equilibrium point. In figure 2, it is shown that then we increase the value of mu, where mu is the implementation rate of awareness program, then the density of water resources increases. Figure 3 shows that when we increase the mu, then the density of unobserved population decreases. Figure 4, it is found that from the figure 4, when we increase the value of R2, then the density of water resources increases. Result: our model portrays how the public attitudes are changed by the awareness program to alter the communication structure and in this manner influence the future conservation of water resources. It is found that the growth rate of constant of unobserved population R1 and depletion rate of fresh water by awareness program by other population can destabilize the system. We see in numerical simulation that as we decrease the value of beta, then the density of water resources increases. We also see that as we increase the value of R2 and mu respectively, then the density of water resources increases. There are some references which is useful for my literature review. Thank you.
Anna, go back to your model, please.
Okay, sir.
Show me the model.
Yes, sir.
Okay. Can you explain the last term of second equation?
Mu naught m.
Last term of second equation.
Yes.
R2 m upon p plus m and mu.
Yes, sir.
Just explain it.
R2.
What does this term represent?
So this term is represented when we implement the awareness program, then the unaware population is made a new class, aware class, is the rate of R2 and T is the half saturation point, the constant represent T. The constant T.
This small p term, you have written m upon p plus m.
Yes, sir.
What is the role of this small p here and how does it affect the dynamics?
So the constant T represents the density of aware population at which half maximum value of R2 and mu reach, then the density of awareness program is equal to P.
Suppose p is 0, then what will happen?
Then, sir, in the model we are taking the P is greater than 0.
What is the need of taking p greater than 0? That's true. But if we take p as 0, what will happen to the model?
Then we take the P is 0, then the term is minus K R2M.
It is R2 new and same term is added in the third equation. So how, when P greater than 0 is taken, how this dynamics is affected? That's what my question is. Because if P is 0, it is simply R2 new, right? And when M upon P plus mu M is added, then how this dynamics is affected? What is the effect of this small p on the system? Just think of this. Any questions from the audience? Any questions from the audience? Thank you, Anna. Thank you very much.
Okay. Okay. Thank you, sir. Thank you, ma'am. Now, next paper will present Sandhya Rani ma'am, Verma ma'am. The topic is modeling the effect of sanitation in a human habitats to control the spread of carrier-dependent infectious diseases due to environmental degradations. So, ma'am is ready.
Sandhya, are you there? Probably she is muted.
Hello. Yes, sir.
Oh, okay.
Ma'am, are you audible?
Yes, sir. Yes, sir. My
Okay.
screen is visible, sir?
Yes, yes, visible. So proceed. Ma'am, please.
Good afternoon. Good afternoon. Presentation is modeling the effect of sanitation in a human habitat to control the spread of carrier-dependent infectious diseases due to environmental. First,
Your net is unstable, I suppose.
Sandhya, if you check with your bandwidth, like your internet isn't working well, तो आपका आवाज थोड़ा रुक के आ रहा है.
You are not audible, Sandhya.
The management of human memory, it to health,
Voice is not clear, yes.
That is the patient. Okay.
संध्या, अगर आप change कर सकते हैं, like if you can change your internet service provider, take a hotspot or like connect with the Wi-Fi or something.
Okay, I'll connect it to
Do any other network. Yes, please do that.
Okay, 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 okay.
Sandhya, are you comfortable?
Sir, I believe she is changing the network. Maybe like she's connecting again.
If there is a delay, she can be asked to present later.
Later.
Let other candidates come.
Hello, Garima ma'am.
Yes, sir.
Yeah, is there a problem?
No, sir, like a participant is not able to connect well, like she has internet problems. So, Rajan sir, if
Yes,
we can
yes, ma'am.
announce the other
We can
name.
take next participant.
Yes.
Sandhya ma'am, we can, she can proceed in last.
Yes.
Okay. So next participant will be Mr. Ashish Kumar Mishra, sir. The topic is modeling the effect of greenhouse gases on global warming. Sir is ready? Ashish Kumar Mishra, sir, are you ready for presenting paper?
Yes, he's sharing his
Yes.
screen.
Sir, I am audible?
Ashish, you continue. Ashish, you start your presentation.
Ashish, you need to unmute yourself. I believe like you were
Ashish Kumar
speaking.
Sharma Mishra, sir, please unmute yourself.
My
Yes,
topic,
yes.
my
Yes, yes.
topic, voice is clear.
Yes, 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 sir. Proceed, please.
Modeling the effects of, my topic is modeling the effects of greenhouse gases on global warming. Global warming is one of the most important problems that our society faces today. Now, methane is a major contributor of global warming. Methane, the elevated level of methane in the Earth's atmosphere, which is about 16% of all greenhouse gases, is a matter of great concern due to its large impact on climate change. In this paper, a nonlinear mathematical model is proposed and analyzed to study the increase of average global warming temperature caused by emission of methane due to production process of rice paddies and farming of livestock populations simultaneously. Now, in this paper, my assumptions, the emission rate of methane is assumed to be constant, say Q. The growth rate of biomass density of rice paddies is assumed to be governed by logistic equation. The cumulative density of livestock populations is also assumed to be governed by logistic equation. Next one, mathematical model. To formulate the model, here 4 dependent variables. First is BT, denote the cumulative biomass density of rice paddies. Next, CA of T, the cumulative density of livestock population. C with the concentration of atmospheric methane, and T with the average global warming atmospheric temperature over its equilibrium. In the modeling process, the following feasible assumptions are taken into account. Next, dV by dt equal to SB of 1 minus B by L minus S1 BCF. Here S increasing, S and L are the intrinsic growth rate and carrying capacity. S1, that is a depletion rate coefficient of biomass, cumulative biomass density of rice paddies due to cattle population, due to livestock populations. Second equation, dCA by dt equal to RAC of 1 minus CA upon K plus RA1 BCA minus R0 CA. Here RA intrinsic growth rate of livestock populations, K which is a carrying capacity, R0 is the depletion rate coefficient of livestock populations due to harvesting for meat, leather, etc. Q0 is the emission rate of methane due to natural sources, and lambda naught represents its natural depletion rate coefficient. See next, where the symbols are described below. Next, equilibrium analysis. The model system 1 to 4 gives 4 equilibrium, namely E0, E1, E2, E star. The existence of E0, E1 and E2 is obvious. The existence of E star can be proved as given below. Existence of E star, the equilibrium values of variables contained in E star are obtained by solving the equations as given below. We find B star, C star, T star. Thus, the equilibrium E star exists uniquely. Next, stability analysis. By computing Jacobian matrix corresponding to the model system 1 to 4, it can easily be checked that E0 this is a saddle point unstable manifold in BCA plane and stable manifold in CP plane. E1 is a saddle point unstable manifold in B direction and stable manifold in CA-CP plane. E2 is a saddle point unstable manifold in CA direction and stable manifold in BCT plane. Next theorem, the equilibrium E star is found to be locally asymptotically stable without any condition. Proof, the Jacobian matrix computed for this. From the above matrix, it is easy to check that one eigenvalue is negative, whereas other eigenvalues can be obtained by the characteristic equation given below. Characteristic equation Z cube C1 Z square. It is a polynomial Z cube of third degree C1 C2 C3. It is noted here that all coefficients Ci is greater than 0. I equal to 1, 2, 3, and C1, C2 minus C3 is greater than 0. By using Rao-Hurwitz criteria, we know that E star is locally asymptotically stable. In the following, the reason of attraction as a lemma for establishing the non-linear stability character of E star is given lemma, and the reason of attraction for all solution of model 1 to 4 initiating in the positive octant is given by the set omega. Next theorem, the equilibrium star is non-linearly asymptotically stable unconditionally. Let U be a positive definite function as follow, where M1, M2, and M3 and M4 are positive constants and can be chosen suitably. Now it is differentiating with respect to t. We find du by dt using all the values, all the different values from system 1 to 4 and simplifying we get d by dt after some algebraic manipulation and by choosing m1, m2, m3. It is noted that d by dt this is negative definite, thus E star is non-linearly asymptotically stable. Next, numerically simulation and discussion. With the help of map-letting using the following values of various parameters, the equilibrium values of different values in E star are obtained as B star, C star, C star, and T star. The eigenvalues corresponding to the eigen equilibrium E star are all negative. Since all the eigenvalues are negative, the interior equilibrium E star is locally asymptotically stable. Non-linear stability of E star. Non-linear stability of E star for the model system 1 to 4 in BCAT plane. It shows that trajectories with different initial stars have been plotted in BCAT plane. It is apparent from that all trajectories approach the equilibrium E star, showing that the equilibrium E star is non-linearly stable for these set of parameters. Next, in figure 2 and 3, C, that is concentration of methane, variation of methane concentration C with time t for different values of R naught depletion rate coefficient. When R naught increases, the concentration of methane and average temperature T with the time t for different values of R naught, the depletion rate coefficient of livestock population due to harvesting are plotted, which shows that C and T decreases as R naught increases. See, next, in figure 4 and 5, the concentration C of methane and average atmospheric temperature T increases as lambda 1 increases. In figure 6 and 7, the concentration C of methane and average atmospheric temperature T with time t is plotted, which shows that C and T increases as lambda 2 increases. From these graphs, it is concluded that methane concentration decreases with harvesting of livestock population, but increases with the increase in the biomass density of rice paddies as well as increase in livestock population. Variation percentage increase in temperature with respect to percentage increase in methane concentration. On comparison, we find that an increase of about 13.67% in methane concentration results in an increase of 1% in average atmospheric global warming temperature. Next conclusion. It has been shown analytically and numerically that as the concentration of methane emission increases with time due to increasing growth rate and cumulative density of rice paddies and livestock population, the global warming average temperature increases. However, due to harvesting of livestock population, the global warming temperature decreases. It has also been shown from the model analysis that for an increase of about 13.67% in methane concentration, the increase in average atmospheric temperature has been found to be of 1%. Some references.
Thank you, sir, for your nice presentations. Sir, please ask any question.
The audience may please ask any questions.
Audience, if you like to ask any question, you may ask. Any question towards audience side? No question.
Okay, Ashish, thank you so much. Now please call upon the next candidate.
Okay, the next paper will be presented by Mr. Ravindra Gupta, sir, on the topic modeling the effect of TV and social media advertisement on the dynamics of the vector-borne disease malaria. So Ravindra Gupta, sir, are you ready?
Yes, sir.
Okay, sir, please proceed your paper.
Good afternoon, sir. My name is Ravindra Kumar Gupta, research scholar under the supervision of Professor A.K. Misra, Department of Mathematics, Institute of Science, Banaras Hindu University. Title of my presentation is Modeling the Effect of TV and Social Media Advertisements on the Dynamics of Vector-Borne Disease Malaria. This is the outline of my presentations. Introduction. Vector-borne disease malaria is caused by pathogens which are transmitted through the vectors. The disease is transmitted indirectly through the bite of infected mosquitoes to susceptible humans. Media, TV and social media play a vital role to control the outbreak of the disease. Some papers and model were also developed before. And the first model was developed by Rolls, which is SI models. It suggests that control of the malaria ETV is necessary to reduce the number of Anopheles mosquitoes beyond a certain threshold. Similarly, Wan and Q and Misra et al. Use media programs to control the epidemic outbreak of the disease. The proposed model is here. HS denote the susceptible humans, HI infected humans, aware humans, susceptible vectors, infected vectors, and total number of TV and social media advertisements. Susceptible human. Hello. Hello. Susceptible humans are infected due to the bite of infected vectors, and they enter into the infected class. Susceptible humans are aware through the awareness program from the media. They join the aware human class. Infected humans recovers and they lost immunity and then joins the susceptible humans. Aware humans lose their awareness and again joins to the susceptible humans. Susceptible vectors, growth of the susceptible vectors is proportional to the total number of vectors, and loss is due to the density dependent loss. And susceptible vectors, when bite to the infected vectors, they acquire the pathogens in them and they become infected. They join the infected vector class. And aware people reduces the density of the bacteria by cleaning the environment and destroying the state of the mosquitoes where they grow. Total number of TV and social media is the growth of total number of TV and social media is depending on the infected human. T0 is the basic baseline of the total number of TV and social media advertisements, which always exist in the system to avoid the risks of epidemic. R0 is the depletion rate, because after some time some media may lose their effectiveness, so that has to be stopped time to time. This is the flow diagram of my model to different compartments. This is the parameters descriptions. Parameter descriptions. The region of attraction is all the solution of the system that initiate in the positive earth and confine in this region. We have three equilibrium: disease and vector free equilibrium, disease free equilibrium, E0, E1 and E steric. The disease free equilibrium always exists in the system, and disease free equilibrium exists only if R is greater than 5A by dH into L, that is RA is greater than, only if growth rate of the vector population is more than their decay rate. R is equal to BV minus BV. Solving the equilibrium equations, we can find the existence of endemic equilibrium. We get these equations, and at F0 value is positive for our basic reproduction is greater than 1, and FIP A by alpha ds is negative. Therefore, there exists a solution in between 0 and IP, and for F dash I is less than 0, there exists a unique endemic equilibrium. The basic reproduction number, which is found using next generation matrix method, and here we have seen that transmission rate from human to vector and from vector to human, if they increase, R0n increases, and the disease may persist in the system. It may increases, it may be more than 1, so the disease may persist in the system. Stability analysis are performed from Jacobian matrix using Raoult's criteria. We have a theorem regarding this. The disease and vector free equilibrium exists and locally asymptotic is stable. If R is less than this E0 becomes unstable if R is greater than 5L by ds. And disease free equilibrium E1 exists, is stable till R0s basic reproduction is less than 1. Otherwise, endemic equilibrium E steric persists. The local stability and equilibrium of the endemic equilibrium is obtained by Lipnov methods. We have obtained this condition using Lipnov functions, where Gi is the variational matrix, J is related at E steric. For the numerical simulation, we have used these parameters unless otherwise stated. We have plotted the equilibrium curves of infected humans with respect to transmission rate from human susceptible human to infected humans. For the values of phi is equal to 0.001, 0.002 and 0.003. All three curves show forward transcritical bifurcation. You can see that this is a forward transcritical bifurcations. At this point, RG, the value of basic reproduction is equal to 1. And as the value of beta HB increases, basic reproduction number value becomes greater than 1, and therefore disease persists in the system in endemic equilibrium. And for the higher value of phi, we get the two saddle nut bifurcations, and more higher value we get the hop bifurcations and two hop bifurcation and saddle nut bifurcations. Therefore, in this case, where we get hop bifurcation, it is difficult to decide how it is quite difficult to take the decision to which strategy to be used to control the disease. This is the equilibrium curves of infected humans with respect to the phi for different value of beta Vs. We have seen that for lower value of phi in all the cases for all values of beta. For lower value of phi, whatever is the value of beta, we see unique endemic equilibrium. As the value of phi increases, disease will die out or it takes the lower values at the transcritical bifurcations. And for higher value of beta, here also we have seen that we get 2 saddle node bifurcations, 2 hop bifurcations, 1 transcritical bifurcations. And these 2 hop bifurcations are supercriticals, and therefore bubbling of phenomena will be seen. The limit cycle starts at one hop bifurcations and ends at other bifurcations. And in such cases, it is difficult to decide how to control the disease, because sometimes the disease go to the higher values and infection go to the higher values, or sometimes it comes to the lower value. It oscillate, I mean. We can see that the limit cycle curve, it starts from this hop bifurcations, goes on, and then ceases to this. After that, we can make some decisions, but from this to this point, it is very difficult to decide for accurate strategies to control the disease. And for beta VS 2 into 10 power minus 6, in the intermediate value, we get this limit cycles orientations, take the different orientations. This is also the equilibrium curves of infected humans with respect to the phi for different value of beta HV, human to vector transmission rate. It is seen that for beta HV 0.002, we get a stable equilibrium points. As the value of phi increases, then it goes to the infected human goes to 0. That is, disease can be controlled. For higher value of phi, we again get saddle node and hop bifurcation, and therefore the scenario will be complicated, difficult to take any decision to control the disease. It means that only phi, which is the per capita reduction rate in the vector population due to aware humans, cannot control the disease if transmission rate is very high. Therefore, we have to control the transmission rate also to control the disease. This indicates. The next figure is similar to the above figure, but this is the equilibrium curves between infected humans and lambda, transmission rate of susceptible people to aware classes. And we have seen that for the higher value of lambda, the curve extends and we get the stable. Blue color shows the stable equilibrium and red color unstable equilibrium. Stable equilibrium at higher level. It means that only awareness cannot all control the disease. At higher beta VS, transmission rate from susceptible vector to the infected vectors. If it is high, then disease also persists in the system. It means that this transmission rate also has to be decreased along with the increase in the awareness program to control the disease. Conclusions. The system undergoes transcritical saddle node and hop bifurcation for wide range of parameter values. The system shows bistability behavior either between two stable or between stable equilibrium and stable limit cycle. For lower value of transmission rate, spread of the disease can be controlled by intervention of the aware class people in reducing the vector spreading size. But with the increasing transmission rate, it would be difficult to limit the spread of the disease as the trajectories either enter the stable oscillatory region or may converge to the stable limit point. For higher values of transmission rates, even higher dissemination rate of awareness program could not efficiently control the disease. So to control the disease anyhow, where transmission rates are to be reduced. This is my references. Thank you, sir.
Thank you, Niranjan sir.
Ravin Gupta ji.
Yes, sir.
Can you show your model again? Please show the model. The last equation is dt upon dt is equal to this thing, right?
Yes, sir.
What this first term, how did you model this? Please explain the first term of the last equation. U1 minus theta is this into h1.
The total number of TV and social media advertisements is decreasing function of awareness humans. Aware humans. It decreases with this factor. Efficacy is theta. And why it happens means if the aware people increases, then there is no use of increasing the awareness program in total media, TV and social media. So if H is increasing, T must decrease. We have to minimize the total because it is cost. No, it takes some cost to for the awareness program from TV and social media.
That's right. That you take care from here. This term HA upon Q plus HA, right? So if you know Q increases, then it has certain effect. Why it is 1 minus theta of something? 1 minus theta. Why it is 1 minus?
We have taken the growth rate, sir, and it is decreases by this factor, and total growth rate will be 1 minus theta HA by Q plus HA. It is growth rate. It is increases. Right. So if you take simply this minus, then it is decreasing, no?
Okay. So this last equation represents your TV and social media dynamics, right?
Yes, sir.
So nowadays, if you look at the entire social media, is very much used for rumor propagation.
Yes, sir.
Can you think of a situation where this rumor propagation can be stopped or at least curtailed using the social media awareness programs?
I think we have to use here for T minus some, that is fake media.
You just think of this situation, because social media is a very strong platform which can very effectively be used to contain the rumor propagation, which is in fact an hazard in today's world. A simple rumor can, put fire in the society. So how this social media platform using mathematical modeling can be beautifully used to contain the rumor propagation. Think of this.
Yes, sir.
Okay. Yes, another my observation is you have used the data in the simulation, which seems to be without any units. Is it the hypothetical data that you have taken just to satisfy your conditions, or this data you have taken from the literature?
Some of the data is from literature, sir. Some of are hypothetically used.
So, but you have not mentioned any unit.
Yes, sir. I have to mention. Yeah.
Your model is not dimensionless, Our model has certain dimensions. So either you use the data from literature and give the reference to that, or else say it is the data taken hypothetically just to satisfy the conditions of the model, right?
Yeah.
Okay. Thank you. Very beautifully presented. Any question from the audience?
Any question toward audience side, please ask.
I think audience nobody is responding from the audience.
Yes. Please ask any question if you have.
Because the very purpose of this
good times are sir between us. He guide me, all of us. If you ask any question, then sir has guided all of us. Please ask any question. We should not lose this good opportunity. Please ask.
But this presentation, the purpose of these presentations is to motivate and stimulate the interest of the youngers, especially.
Yes,
and
yes.
I think if you are following, you must be curious also to ask something. If you have any queries, please put forward. Else you can discuss it later on as well. So I think there is no query. So proceed further. The next candidate, Niranjan Swarup, is not available today, as I must
So the next paper will be presented by Sumitra Pal sir, paper ID 61. The topic is dynamical behavior of a stage structured predictor prey system with hunting cooperation and fear in the presence of two discrete delay. Sumitra Pal sir.
Are you there?
Yes, sir.
61 ID, paper ID, yes.
61. Am I audible, sir?
Yes, yes, okay. Please proceed.
Okay, sir. Yes, good afternoon to you all. Myself, Soumitra Pal, research scholar in the Department of Mathematics, Institute of Science, Banaras Hindu University, working under the supervision of Professor A.K. Misra. Topic of my presentation is dynamical behavior of a stage structured predator system with hunting cooperation and fear in presence of two discrete delay. This is the outline of my presentation. So nowadays, in last few years, the idea of considering non-conjunctive effect, that is fear of predator, along with the direct killing, it attracts so many researchers in working in this field. So, and this has been observed by many field experiments done by ecologists that actually this non-conjunctive effect actually impacted on the demography of the prey population. Some of the experiment done by Janet et al. And Serif et al. And depending on the behavioral differences and reproductive capability and dependency, lifespan of any species is usually divided mainly into two classes, namely immature and mature. And also, we can see that predator species adopt some various traits to maximize their predation. One of commonly observed strategies is that cooperation in hunting. So, considering these things, we have developed a model where we considered prey population and predator population, and we also incorporate the delay in the model system. That X here, X and Y, X denoting the immature prey and Y denoting the density of mature prey, and the growth rate of immature prey taken proportional to the density of mature prey, and here D is the natural death rate of prey population. This term R e to the power minus d tau 1 into xt minus tau 1, this represent the density of immature prey take birth in the t minus tau 1 times and survive through time t. And here alpha xz, the functional response, alpha is the predation rate, and here S is the birth rate of mature prey. And as we incorporate the fear in the density of mature prey, so S is multiplied by a decreasing factor 1 plus k lambda z. K is the fear factor and lambda is the hunting cooperation parameter. We considered that predator population only cooperate during the hunting of matured prey. So the predation rate beta is modified by beta plus lambda z, and here S0 is the density dependent death rate of mature prey. And in the third case, that is in the case of mature predator population, A0 is the natural death rate, and A1 is the density dependent death rate, and C and C1 is the conversion efficiency. So these terms are the numerical response corresponding to the functional response. So if we consider the non-delayed system, that is if we put tau 1, tau 2 equal to 0 with the system 1 reduced to the model system 2. Now we study the models qualitative analysis about the models. First, we obtain the equilibrium of the system. So we observe that trivial one, that is 0-0 equilibrium, always exists, and predator free equilibrium exists with some condition, and this is the condition SD plus SR plus R square minus D square minus DR greater than 0. And the interior equilibrium is obtained by solving these two equations given by equation number 3 and 4. And we can see the graphical representation of equation 3 and 4. From there, it will be very clear about the intersection of these two curves. First, blue curve, if the x-intercept of blue curve is less than the red curve, that is equation 4, x-intercept of equation 4 is less than equation 3, then there exists only one intersection, that is one interior equilibrium. And if the x-intercept of red curve is less than blue curve, then three conditions may arise. First one, two intersection, positive intersection may be there. They may touch at one tangential point and they may not touch. So in that case, either two interior equilibrium or one interior equilibrium or no interior equilibrium may exist. And for stability analysis, we obtain the Jacobian matrix at the equilibrium point, and from the eigenvalues of that Jacobian matrix, we can state that whether the equilibrium is stable or unstable. We obtain that trivial equilibrium is always unstable and pre-dated phi equilibrium is stable with some condition, and the interior equilibrium is stable if the coefficient of the corresponding characteristic equation follows Routh-Hurwitz criteria. And for the delayed system, the characteristic equation is this, given in equation number 6, and with some mathematical calculation, we obtain that transversality condition we obtain here, that is h-1 of omega 1 square not equal to 0. So we can conclude with following theorem, that if tau1 equal to 0, that is we are considering such case when tau1 equal to 0 and tau2 can take any positive value. Case, if the transversality condition holds, then there exists a critical value tau2 0 at which Hopf bifurcation occur, and the value of tau2 less than tau2 0, the system will be stable, and for higher values of tau2, that is greater than tau2 0, that critical value, the system will be unstable. And if the characteristic equation have two positive roots, then the situation may arise that system will switches its stability from stable to unstable and again regain stability. This complete cycle may occur more than once. So stability switching, what we call that stability switching. So stability switching in that case may occur in the system. And to validate our analytical findings and some more underlying dynamics, we perform the numerical simulation with the given set of parameter values. Here we can see that the fear factor K have stabilizing effect, and that is lambda hunting cooperation factor as destabilizing effect on the system dynamics. And that we can see that with respect to S0, system can show forward bifurcation as well as backward bifurcation depending on the value of that fear parameter. That is, we can see that if we take K equal to 1, then the system shows forward bifurcation, and if we keep the parameter values K at 0.15, the system shows backward bifurcation. So in this case, the bistability condition occur in between this TC point and SN point. So if we consider a value of S0 between this TC point and SN point, so the system will show bistable behavior, and one such scenario, phase portrait of such scenario is displayed in figure C. So here, depending on the initial condition, the trajectories will either goes toward the attractive interior equilibrium point or stable boundary point, that is pre-dated free equilibrium. Yes, sir.
Sumit Pal, at K is equal to 1, there is a forward bifurcation, and at K is equal to 0.15, there is a backward bifurcation, right?
Yes, sir.
Why this is happening?
Why this is happening? At least usually from previous figure, Yes, sir. I am getting your question. From previous figure, it is clear that with the value of k, the system gains stability.
Then my question is why it depends on so heavily on k that if there is a minor change in the value of k, the bifurcation changes.
Actually, the answer, I am explaining that answer, sir. If we increase the value from previous figure, we can see that if we increase the value k, the system gains stability.
Okay.
Now, if we draw equilibrium curve with respect to S0, for particular S0, if we increasing k, the system will gain stability. So
And
here
this is,
we can see that.
and this
if
is
we
for your
take,
model only, right?
If we take higher values of k, then system is stable for larger interval of S0, and backward bifurcation symbolizes that if we lower the value of k at, that is, if we take k equal to 0.15, the region of stability is.
Can you find a range for the values of k between which it is it shows the forward bifurcation and otherwise backward bifurcation? Because when k is 0.15 and k is 1, these are just 2 points. Can you find out a range for the values of k, where range of
Yes,
for
sir,
the values of k?
We can obviously find the range. It needed rigorous simulation. It is put particular value of k, and we have to check whether it shows forward bifurcation or backward bifurcation.
Right,
Then
right.
we can
So I mean, there is little sensitivity analysis you have to also do, how sensitive this parameter is, because it
Yes,
changes
sir.
sign with respect
Yes,
to the change in the value of k. Okay, continue.
Actually, fear parameter is the main parameter. Fear parameter and the hunting cooperation parameter is the main parameter. So,
all right. Just summarize.
Okay, sir. And now with the inclusion of delay parameter, that is tau2, that for different values of tau2, we see that systems show different types of dynamics, sometimes stable and against unstable, and then against stability. So this figure shows the stability switching phenomena with respect to tau2. That is, first, for lower values of tau2, it is stable, then become unstable, the gains stability in this region. The values of tau2 and never regains stability. And here we show that sensitivity of the trajectories when tau2 equal to tau2, we take 17. That is, for very tiny differences in the initial point, the trajectories never regains its original path. That is, they diverges from each other with respect to time, and which shows which hints the chaotic behavior of the system, chaotic behavior in the system. So, which is confirmed with the diagram of maximum Lyapunov coefficient with respect to tau2. The positive value of maximum Lyapunov exponent guarantees that system enters into its chaotic regime. And here is the stability region of the interior equilibrium in k tau2 plane, biparametric plane. Here blue region is the stable region and cyan region is the unstable region. And we can again see that for higher values of k, that is, if we take k equal to 0.9, we can see that system gains stability only once. Firstly, it was stable and gains stability for only once for intermediate value of tau2. And if we take the value, suppose k equal to 0.5, system gains stability twice. And for further lowering the value of k, that is k equal to 0.2, if we take, the system gains stability thrice. That means stability switching phenomena increases with the lowering values of k. So this gives the very interesting dynamics in this biparametric plane.
Sumit, please conclude.
Okay, now I'm coming to my conclusion section. That is, fear factor has stabilizing effect on the system dynamics, as I saw, while the hunting cooperation factor is having the unstabilizing effect. And for higher values of k, the otherwise stable system loses its stability even if the fear response delay is very small and never regains stability. Whereas for relatively lesser values of k, though system becomes eventually stable for a higher time delay but regains stability finite times in some intermediate interval of time delay. It is also observed that with much larger fear response delay, the system events enter into chaotic design after showing some higher periodic oscillation. And these are some references. That's all. Thank you.
Any questions from the audience, please?
Audience, if you have any question, then please ask. No question.
Okay, call the next candidate.
Okay, so next paper will be presented by
thank you, sir.
Jyoti Maurya ma'am on the topic bifurcation analysis of an epidemic model with the limited number of hospital beds. So, Jyoti Maurya ma'am,
Yes, sir.
please proceed your paper.
Sir, is my screen is visible?
Okay, no. Yes. Yes, your screen is visible.
Good afternoon to all. My name is Jyoti Maurya and I am a research scholar at Department of Mathematics, PhD, under the supervision of Professor A.K. Mishra. The topic of my presentation is bifurcation analysis of an epidemic model with limited number of hospital beds. These are the outlines of my today's presentation. Now I will start with the introduction. As we know that there are several infectious diseases which spread in the human population through person-to-person contact, and the transmission of these infectious diseases is very intricate, and the availability of medical resources such as medicines and hospital beds and etc. And some other medical equipments substantially affects its control measure. Some developing and developed countries also use the hospital bed population ratio is used by the healthcare planners as an approach of capturing the availability of healthcare services delivery. But how many number of hospital beds and estimating this number remains a challenge and therefore a serious concern for public health. So we developed a mathematical model with three classes: susceptible, infected, and hospitalized class. Here S is the susceptible class. In susceptible class, A is the immigration rate, which includes the immigration from outside and also includes the birth rate. Here beta is the transmission rate, which means when susceptible individuals come into contact with infected individuals, they get infected and join the infected class. Here D is the natural mortality rate and nu is the self-recovery rate of infected individuals. Here nu1 is the hospitalized recovery rate, hospital recovery rate, which means when infected population get admitted in the hospital and recovered from the hospital, they again join the susceptible class with this rate nu1. Here I is the infected class. In this class, alpha is the disease-induced mortality rate. Here H is the total number of hospital beds, and as we know that H is the hospitalized population at any instant of time. So this quantity HA minus H represents the available number of hospital beds at any instant of time. So infected individuals try to get the available number of hospital beds HA minus H and join the hospitalized class with this rate K1. Here K1 is the hospital occupancy rate. In hospitalized class, some hospitalized population also experience some extra mortality. So here theta is the extra mortality constant. Now this is the basic reproduction number for our proposed model. Now from the analysis, we obtained that the disease-free equivalia E0 is always exists. For R0 greater than 1, a unique endemic equivalia E1 star exists.
And if R0 equal to 1, then a unique endemic equivalia exists provided M is less than 0. Otherwise, there is no endemic equivalia. If R0 is less than 1, there exists two endemic equivalia, E1 star and E2 star. If and only if delta 0 is greater than 0 and M is less than 0. And these two endemic equivalia collide and unite into a unique endemic equivalia E3 star when this delta 0 is equal to 0 and M is less than 0. Otherwise, there is no endemic equivalia. The quantity M and delta 0 are represented by this expression. Now, for the stability analysis of obtained equivalia, we first calculate the Jacobian matrix and found that the disease-free equivalia E0 is locally asymptotically stable when the basic reproduction number is less than 1, and if this basic reproduction number is greater than 1, it becomes unstable. For R0 greater than 1, the unique endemic equivalia E1 star is locally asymptotically stable if and only if A1, A2 minus A3 is greater than 0. For R0 less than 1, the endemic equivalia E1 star, if exists, is locally asymptotically stable if and only if A1, A2 minus A3 is greater than 0, whereas E2 star is always unstable. Now for the transcritical bifurcation, we use the central manifold theorem and found that this quantity L1, if greater than 0, then backward bifurcation occurs. And if this quantity is less than 0, then a forward bifurcation occurs. Now for the saddle node bifurcation, we use the Sotomayor theorem and found that K1 is not equal to, if K1 is not equal to beta C D plus delta alpha by D, then a saddle node bifurcation occur at the unique endemic equivalia E3 star. Now for the Hawk bifurcation, the necessary and sufficient condition for the occurrence of Hawk bifurcation around the endemic equivalia E1 star is that there exists a beta equal to beta star such that these two conditions holds. These parametric values. Now, if we take the value of hospital occupancy rate equal to 0.007, then forward bifurcation occurs. And if we slightly increase the value of hospital occupancy rate to 0.0012, then backward bifurcation occurs. Now the saddle node. Now the supercritical Hawk bifurcation occurs if we take K1 equal to 0.00124. In this figure, the supercritical Hawk bifurcation, forward bifurcation occur and it disappear via backward supercritical Hawk bifurcation. And if we take the value of K1 equal to 0.0013, then supercritical Hawk bifurcation disappear via homoclinic bifurcation. Now, in this case, if we again slightly increase the value of K1 to 0.002, the limit cycle bifurcation occur. In this case, two limit cycle, one unstable and stable, collide and disappear via limit cycle bifurcation. Now, for the value of K1 equal to 0.006, a subcritical Hawk bifurcation occurs. Now, if we plot the bifurcation diagram in R0 K1 plane, then these three curves, homoclinic, Hawk, and saddle node curve, divide the whole region plane R0 K1 into 4 regions. And these are the phase portrait diagrams for the values of R0 and K1 taken from these different 4 different regions. Now, if we plot the bifurcation diagram in R0 alpha plane, we obtain the generalized Hawk bifurcation. Now, from the conclusion, the proposed model recognizes a collection of bifurcations such as transcritical, saddle node, supercritical, subcritical, and Boutin bifurcation. The phenomena of transcritical bifurcation in backward direction has a significant public health implication, that is, basic reproduction number should be less than 1 for the eradication of epidemic outbreak is not sufficient. The hospital beds and hospital occupancy rates are crucial factor for the control of dispersion of an infectious disease.
These are some references which we have used. Thank you.
Thank you, ma'am, for your nice presentations. Sarah, any question, please?
It's very good. Any question from the audience? Thank you, Jyoti.
Okay, sir. So thank you, Jyoti, ma'am. So now next paper will be presented by Anjali Jha, ma'am, on the topic effect of budget allocation on the abatement of atmospheric carbon dioxide, a modeling study. Over to Anjali Jha, ma'am.
Anjali, are you there? Anjali Jha, are you there in the network?
Yes, sir.
Okay, okay. Anjali Jha, ma'am, please proceed.
Yes, sir. My slides are visible.
Yes, yes, visible. Please proceed.
Good afternoon to all. Myself Anjali Jha. I am research scholar in Department of Mathematics, Banaras Hindu University. I am working under the supervision of Professor A.K. Mishra. Today, the topic of my presentation is effect of budget allocation on the abatement of atmospheric carbon dioxide, a modeling study. These are the outline of my presentation. Moving towards the introduction, as we know that the world is facing several problems due to increasing greenhouse gases, such as sea level rise, temperature rise, increase in incidence of vector-borne diseases, etc. Among all the greenhouse gases, carbon dioxide is the main greenhouse gas due to its high presence in the atmosphere compared to other greenhouse gases, as it contributes to 76%. Anthropogenic emission of carbon dioxide due to fossil fuel burning and land use changes are the root cause for increasing concentration of carbon dioxide. To reduce the atmospheric level of carbon dioxide, several strategies are being implemented globally. Some mitigation efforts use decarbonization technique in which anthropogenic emission of carbon dioxide is being controlled, and in other techniques which are termed as negative emission technique, in which carbon dioxide is absorbed directly from the ambient air. As the application of any mitigation effort would require budget, so it is reasonable to analyze the effect of budget allocation on the abatement of atmospheric carbon dioxide. And for that, we have proposed a nonlinear mathematical model. For model formulation, we have considered 4 dynamical variables, which are atmospheric concentration of carbon dioxide, human population, forest biomass, and the budget. The allocated budget is used in 2 ways. Some part of budget is used to control the anthropogenic emission of carbon dioxide, and the remaining part of the budget is used for the afforestation and reforestation programs. This is our formulation model. Here, alpha is the natural depletion rate of carbon dioxide, and as the anthropogenic emission of carbon dioxide depend on the human activities, so we have taken it as proportional to the human population n. Here, lambda is anthropogenic emission rate coefficient. As we considered that K's part of the budget is used for the control of anthropogenic emission. So anthropogenic emission rate lambda is a decreasing function of allocated budget. And as we know that the forest biomass uses carbon dioxide during the photosynthesis process, so the atmospheric concentration of carbon dioxide decreases due to the forest biomass. We have considered that the human population, forest biomass, and the allocated budget follows logistic growth. As the increasing concentration of carbon dioxide affects the human population negatively, so we have considered this term. And as we know that the human population uses forestry biomass for their livelihood, so the forestry biomass declines by this rate, and this declination in forestry biomass feed back to the growth of human population at a rate pi. We have considered that the remaining portion, that is 1 minus Ks part of the budget, is used for the reforestation and afforestation programs. So the forestry biomass increases with this rate due to the budget allocation. Here we have considered that the atmospheric concentration, with increasing concentration of atmospheric concentration of carbon dioxide, the allocated budget also increases. This is the region of attraction for our formulated model system. These are the parameters and its description which we have used for the model formulation. As the formulated model is non-linear, so it is difficult to analyze it numerically. So we have obtained equilibrium points using so we will analyze the long-term behavior of the model system, and for that first we obtain the equilibrium points, and for that we will equate the growth rate of all the dynamical variables to 0. For our formulated system, we have obtained 8 equilibrium points, and the condition for existence is given here. This is the condition for the existence of interior equilibrium. We have also calculated this value to analyze how the proportion of budget affects the equilibrium level of concentration of carbon dioxide. We have from here we can conclude that when dC by dk is less than 0, then we should allocate more budget to control the anthropogenic emission of carbon dioxide, and when dC by dk is greater than 0, then we should allocate more budget to the for the afforestation and reforestation program. This is the theorem for the stability of obtained equilibrium. We have obtained that the equilibrium E0, E1, E2 and E3 are always unstable, and E4, E5 and E6 are unstable whenever E star exists. Further, we have to analyze the local stability of interior equilibrium E star. We have calculated the Jacobian matrix at equilibrium E star, and the characteristic polynomial is given by this. Using Routh-Hurwitz's criteria, we can say that the equilibrium E star is locally asymptotically stable if the following condition, if this condition holds. Further, we have obtained the global stability condition using Lyapunov method, and these are conditions for the global stability of interior equilibrium E star. Moreover, we have noticed that increasing the value of eta, the local stability condition stated is violated, and there is possibility of Hopf bifurcation around the interior equilibrium E star. This is the theorem for the Hopf bifurcation around equilibrium E star with respect to parameter eta. For numerical simulation, we have used this set of parameter values, and for this set of parameter values, we have obtained this equilibrium, interior equilibrium, and as we can see that the eigenvalues of the Jacobian matrix at E star are these, and all the real part of eigenvalue is negative, so we can say that the E star is locally asymptotically stable for the chosen set of parameter values. We have plotted the solution trajectories for different initial starts, and this shows that the global stability of interior equilibrium E star. Further, we have plotted the variation plot to show the effect of anthropogenic emission rate lambda and deforestation rate phi on the equilibrium level of considered dynamical variables. We can see that as the value of lambda increases, the concentration of carbon dioxide increases and the human population decreases, forestry biomass increases, and as the concentration of carbon dioxide increases, the allocated budget to reduce the level of carbon dioxide also increases. Also, as the value of phi increases, the concentration of carbon dioxide increases, human population decreases, forestry biomass decreases, and the budget increases. Further, to analyze the effect of efficacy of budget to control the anthropogenic emission of carbon dioxide, as well as the afforestation and reforestation programs on atmospheric level of carbon dioxide, we have plotted this figure, and from this we can see that as the value of nu and mu increases, the atmospheric level of concentration of carbon dioxide decreases. Further, we have plotted the equilibrium level of carbon dioxide for different values of K. From this figure, we can see that for small values of K, the atmospheric concentration of carbon dioxide decreases as the value of K increases. After a threshold value of this Kc is equal to 0.5025, on increasing the value of K, the atmospheric level of carbon dioxide increases. So in this case, we should utilize more budget for the afforestation and reforestation programs. Further, we have plotted the phase portraits for different values of eta. From figure A, we can see that for eta is equal to 0.00004, the equilibrium E star is stable, and if as the value of eta increases, there exists a stable limit cycle, and all the solution trajectories approaches to the limit cycle, and after critical value of eta, the system again becomes stable, and all solution trajectories approaches to the interior equilibrium E star. Here we have plotted the Hopf bifurcation diagram. From this figure, we can see that for the small values of eta, the system is stable, and as the value of eta crosses its threshold value, the system becomes unstable and Hopf undergoes Hopf bifurcation. And after increasing eta from a second critical value, the system again becomes stable. Conclusion: from the model analysis, we have shown that the anthropogenic emission of carbon dioxide and deforestation due to human population are the prime reasons for increasing concentration of carbon dioxide. From model analysis, we have shown that up to 50.25% of the budget should be used for the control of anthropogenic emission, and 49.75% of the budget should be used for the afforestation and reforestation programs for the optimal reduction in atmospheric concentration of carbon dioxide. And also we have noticed that interior equilibrium changes its stability from stable to unstable and unstable to stable as the allocated budget increases. These are the few references which we have used. Thank you.
Thank you, ma'am, for your nice presentations. Over to sir. Participant, do you like to ask any question? No question towards participant side? Okay. Any question towards participant side?
I think there is no question.
Okay, sir.
So just call upon the next candidate.
The
Mr.
next
Akash
paper will be presented by Mr. Akash Yadav on the topic effects of insecticide on crop production in presence of insect population, a modeling study. Over to Akash Yadav, sir. Please proceed.
Hello.
Yes.
Is my screen visible, sir?
No, not at all. Please. Yes, visible.
Okay. Good afternoon, everyone. My name is Akash Yadav. I am a research scholar in Department of Mathematics, Banaras Hindu University, under the supervision of Professor Arvind Kumar Misra. Today, the title of my presentation is Effects of Insecticides on Crop Production in Presence of Insect Population, a Modeling Study. These are the outline of my presentation. Now, I start my presentation with introduction. At present time, sustainable crop production is of prime importance due to diminishing cultivation, stable land, and quickly expanding human population. As we know that the attack of insects on crop has always been of big concern and poses a threat to farmers as well as to industrial and economical growth of any country. To overcome this problem, nowadays farmers use insecticide-coated seeds and spray insecticides on plants to reduce the density of insects. In this paper, a non-linear mathematical model is formulated to control the insect population using insecticides and reduce the adverse effects of insects on crop production. This is the mathematical model. Here, A represents the crop production, S is the insect density, and P represents the concentration of insecticides. In this model, since agriculture land is finite, therefore, logistic growth is considered. Due to attack of insects, crop production decreases, and Hollywood type function is used to represent this. Here we have assumed that the growth of insects wholly depend on agriculture crops with Holling type second functional response. Growth of insects decreases due to natural death and also due to intake of insecticides. Here we assume that the spray rate of insecticide is proportional to the density of insects and it depletes due to environmental factors and also due to intake of insecticide by the insects. These are the assumptions. Now, to find the interior equilibrium, we have find the components S is equal to this and P is equal to this as shown in equation 3.1, and the coordinate in A should be the real positive solution of the cubic equation. As we can see from equation 3.1, the values of S and P are positive if A is less than K and A is less than M delta upon theta alpha minus delta. So we have to find the value of agriculture crop production in this interval. Now, to find this value, we use the transformation, and after substituting the value of A, we get the cubic equation 3.3. Here, P1, P2, P3, and P4 are represented here. We can see that P1 is positive and P4 is negative. Therefore, by Descartes' rule of sign, we can say that equation 3.3 has a unique positive root if P2 and P3 are of same signs. However, it may have three positive roots if they have opposite sign. This clearly states that equation 3.2 possesses a unique positive root and thus interior equilibrium exists. Now, the proposed system admits these equilibrium points. The trivial equilibrium always exists. The insect-free equilibrium E1 always exists, and the interior equilibrium exists when agriculture crop consumption rate alpha is greater than its threshold value. Here from this, it is clear that if the agriculture crop consumption rate is below a threshold value, then insects does not exist in the system and the insect-free equilibrium exists. Now, the Jacobian matrix at trivial equilibrium is shown here, and the eigenvalues of the Jacobian matrix at trivial equilibrium is R minus delta and minus phi 0. Since R, that is the growth rate, is always positive, therefore the trivial equilibrium is always unstable. Now the Jacobian matrix at insect-free equilibrium is shown here. Here the eigenvalues are minus R, theta alpha k upon m plus k minus delta and minus phi 0. From this, it is clear that insect-free equilibrium is stable if this term is negative, and this term is negative if crop consumption rate is less than this threshold value. That is, if insects consume the crop less than a threshold value, then insect population decreases and finally does not exist in the environment and insect-free equilibrium exists. However, when crop consumption rate of insects increases, since insects wholly depend on agriculture crops, the insect population increases and interior equilibrium came into existence. Now the Jacobian at interior equilibrium is shown here, and we have find that the interior equilibrium is locally asymptotically stable provided the given condition rho star is greater than 0. Now we come to the bifurcation analysis. The proposed system undergoes a transcritical bifurcation with respect to crop consumption rate around insect-free equilibrium at alpha is equal to alpha star. all the conditions of Sotomayor theorem for transcritical bifurcation are satisfied for the proposed system, and system goes transcritical bifurcation at alpha is equal to alpha star, that is the crop consumption rate at a certain threshold value. Now the system also undergoes the pitchfork bifurcation at a critical point phi is equal to phi star if the conditions 1 and 2 are satisfied. Now we came to existence of Hopf bifurcation. The proposed system undergoes a Hopf bifurcation around interior equilibrium if there exists a critical value and the condition first and second are satisfied. For agriculture point of view, periodic behavior is unpleasant because it implies fluctuations in the amount of insecticides, which makes it difficult to allocate resources. Thus, it is important to identify the situation in which Hopf bifurcation occurs. Now, these are the parameter values which I have used in this model formation. Here R is intrinsic growth rate, K is carrying capacity, alpha is crop consumption rate, M is half saturation rate, theta is conversion efficiency, and so on. And phi 1 is uptake rate of insects, and delta is depletion rate of insects due to insecticide. Now, these are the numerical simulations which I have used to validate the analytical findings. From here, we can see that the transcritical bifurcation plot and the effect of crop consumption rate on insect density. Here we can see that if the insect density is lower, then the insect population decreases. Now this is the effect of spraying rate of insecticide on agriculture crop production, susceptible insect population and insecticides. As we can see, if we increase the spraying of insecticide, the amount of crop production increases while the insect density decreases. This is the plot of pitchfork bifurcation with respect to bifurcation parameter phi, that is the spraying rate at M is equal to 5. These are the Hopf bifurcation taking spraying rate as the bifurcation parameter. From this figure, it is clear that if the spraying rate is less than a critical value, then the system oscillates, and if we increase the spraying of insecticide, the system becomes stable. These are the stable limit cycle and stable equilibrium obtained. Now the conclusion of this paper. In this paper, we have proposed and analyzed a three-dimensional mathematical model to study and control adverse effect of insects on crop production. Bifurcation analysis is performed. The results obtained in this paper indicate that crop consumption rate and spraying rate of insecticides are crucial factors in crop production. Also, the use of insecticide reduces the influence of oscillation and allows the system to become stable in a shorter period of time. From this model, we can conclude that to enhance crop production, it is important to increase the spraying rate of insecticide with the increase of crop consumption rate. These are the references I have used in this paper. Thank you.
Thank you, Akash Yadav, sir. Participant, if you want to ask any question, please ask.
Dr. Rajan?
Yes, sir.
You can call Sandhya Rani Verma.
Yes, yes, sir. Yes, he is remaining, yes. Then next paper will be presented by Sandhya Rani Verma, ma'am. Are you available here? Sandhya, ma'am.
Unmute yourself, Sandhya.
Are you listening us? Sandhya Rani Verma, ma'am?
Yes, sir. Hello.
Okay, okay. So next paper will be presented by Sandhya Rani, ma'am, on the topic modeling the effect of sanitation in a human habitat to control the spread of carrier-dependent infectious diseases due to the environmental degradations. Over to Sandhya Rani, ma'am, Verma, ma'am. Why is it not clear, ma'am? Some disturbance towards your side, ma'am. Yes, yes, audible.
Is it okay, sir?
Yes, yes, audible. Yes. Proceed, ma'am. Yes.
Audible, sir?
Yes, yes, audible. Please proceed.
Okay, sir.
Sanitation refers to proper management of human Sanitation refers to proper management of human excreta, solid and animal waste. It aims to protect human health by providing a clean environment that reduces the transmission of diseases. Inadequate sanitation is an important factor for the spread of infectious diseases such as cholera, typhoid, etc. It also contributes to malnutrition. Improved sanitation is crucial for public health. Access to safe sanitation system includes household discharges, schools, and workplaces, which is very important in reducing the infectious diseases. Some of these diseases, like dysentery, cholera, etc., are called waterborne diseases spread by flies carrying the bacteria of these diseases into the food and water of susceptible population. The diseases such as tuberculosis and measles are spread by airborne carriers in the environment. The transmission of these infectious diseases is further aggravated due to lack of sanitation, leading to unhygienic environmental conditions in a habitat, which provides a very conducive environment to these carriers to flourish. Many researchers have proposed a nonlinear mathematical model to study the spread and control of these infectious diseases. Such as Shukla et al. Has proposed a model with integration for the spread of infectious diseases with bacteria and carriers in the environment, and they have concluded that the spread of infectious diseases increases due to growth of bacteria and carriers in the environment, and diseases become more endemic due to immigration. To control the spread of infectious diseases, certain measures such as vaccination, treatment, and awareness programs among people are taken. But as discussed, sanitation plays an important role in containing the disease. If our environment is clean, the growth of harmful bacteria will decrease, which consequently decreases the spread of carrier-dependent infectious diseases, hence the infected population. Thus, keeping this aspect, we have proposed a nonlinear mathematical model. So, in our model, this X represents the susceptible population, Y represents the infected population, C denotes the carrier population density, EM represents the environmental degradation, FS1 denotes the sanitation effort applied in controlling the carrier population density, and FS2 denotes the sanitation effort applied in controlling the environmental degradation. Here we have taken a constant immigration of the population, and beta is the direct transmission of infectious disease when a susceptible population come in contact with infected population directly, and lambda represents the transmission of disease indirectly when a susceptible population come in contact with the carrier population indirectly, and D denotes the mortality rate. Mu represents the recovery rate when a susceptible population, when an infected population get themselves cured, they again become susceptible population. And here alpha denotes the disease-induced death rate. In carrier population density, we have taken the logistic growth for the carrier population, and here S2 represents the decrement in the carrier population due to the sanitation effort applied, and S3 denotes the increment of carrier population due to the environmental degradation. Here we have taken a constant rate of environmental degradation, and environmental degradation also increases by the rate θ1 due to the human discharges, and θ2 represents the decrement of the environmental degradation due to the sanitation effort applied. For sanitation effort also we have taken a logistic growth for the sanitation effort for both carrier population and environmental degradation. These are the description for the parameters. Then we have taken N, which denotes the total population density xt plus yt. So our model can be rewritten like this. The analysis of the model is done by finding the equilibrium points, and then the stability of these equilibrium points have been done. So we have got 12 non-linear, non-negative equilibrium points, and this is the disease-free equilibrium, and this is endemic equilibrium. Then the stability analysis of the model is being done. So the equilibrium point, we have find that the equilibrium point E0, E1, E2, E3, and E4, E5, E6, E7, E8, and E9, and E10 are unstable, and the endemic equilibrium E11 is totally stable, provided these conditions are satisfied. From here, we can see that as the lambda tends to 0, that is the indirect transmission of the disease. If that tends to 0, then this inequality will satisfy, and here we can see that it theta 1 tends to 0, then this inequality is satisfied. Then the endemic equilibrium E11 is non-linearly asymptotically stable. In the region omega, we have taken this region of attraction, provided the following conditions are satisfied. Then the numerical simulation of the model has been done by using the MATLAB software. These are the hypothetical values which are taken for showing the best conditions for the models. This is the equilibrium value for the model of endemic equilibrium are computed here. And the eigenvalues for the variational matrix for endemic equilibrium are this. And since all the eigenvalues are negative, this shows that the endemic equilibrium is locally asymptotically stable for the above set of parameters. So here is the graphical representation of a model. This is the variation of total human population with infected population and carrier population density. This shows that with different trajectories, all the trajectories reaches to their equilibrium point. Here we have taken a graph for the infected population with time for distinct values of lambda. Lambda represents the indirect transmission of the disease. And as we see that as the value of lambda increases, the infected population also increases. Then the variation of carrier population density with time for distinct values of S2 is taken. S2 is the increment rate of carrier population. So here we can say that as S2 increases, the carrier population will decrease, and here also then if carrier population will decrease, then we can see that the infected population also decreases. Then variation of carrier population with time for distinct values of S3. S3 was the increment of carrier population density due to environmental degradation. So here we can see that as the value of S3 increases, the carrier population density increases, and due to which hence the infected population also increases. Then variation of carrier population density with distinct values of theta 2. Here we can see that as the value of theta 2 increases, the carrier population density decreases, and hence the infected population also decreases. The variation of carrier population with time for distinct values of 5. 5 was the sanitation effort applied to control the carrier population density. So we can see that as the value of 5 increases, the carrier population decreases, which indirectly decreases the infected population also. And then a variation of carrier population with time for distinct values of psi. Psi was the parameter for the sanitation effort applied to control the environmental degradation. So we can see that as sanitation effort is applied to control the environmental degradation, carrier population decreases, and which decreases the infected population also. The conclusion of our paper is, in the presentation we have proposed a nonlinear model to study the role of sanitation in human habitat to control the spread of carrier-dependent infectious disease due to environmental degradation. And in modeling process, both direct and indirect transmission of disease is considered, and it is assumed that the density of carrier population grows logistically with the intrinsic growth rates, and the carrier population density is assumed to be direct proportion to the sanitation effort applied and the environmental degradation. The cumulative density of environmental degradation depends upon human population related factors. To decline the growth of carrier population and to make the environment clean, sanitation effort is applied, which is also modeled logistically. So we can see that as the spread of carrier-dependent infectious disease can be controlled by applying suitable sanitation effort, which makes our environment clean and consequently decreases the growth of carrier population. These are some differences of the paper. Thank you.
Thank you, Sadhya ma'am. Very nice presentations. Participant, if you want to ask any question, please ask. Sir, any question towards your side?
No, Dr. Rajan.
Okay, sir.
Thank you so
So
much. There is
today,
one
more presentation is remaining. Rajat Verma.
Mr. Rajat Verma.
Yes. We can call him. So the next participant will be Rajat Verma, paper ID 30 on the topic optimizing security of IoT using blockchain 4 and cryptography. Proceed to Rajat Verma, sir.
Hello, sir. Am I audible, sir?
Yes, you are audible. Please proceed.
Sir, is my screen visible, sir?
Yes, screen is visible.
Okay, sir. So a very good afternoon to all the honorable dignitaries present over here in this particular conference. The title of the paper is Optimizing Security of IoT Systems Using Blockchain 4.0 and Cryptography. Here are the table of contents that includes the introduction, the rise of IoT, then we have the issues of IoT, then I'll be telling you what is the structure of block and blockchain, then we'll see the hashing as well as digital signature, then I'll focus on the problem statement, then moving on to the analysis of various SHA algorithms, then moving on to blockchain solutions for IoT, and then we'll see the observations, and in the end we'll have results and conclusions following the references. So starting with the introduction, the title of the paper is Optimizing Security of IoT Using Blockchain 4.0 and Cryptography. As we know that the Internet of Things, the term was coined by Kevin Ashton in 1999, but the rise of IoT became evolutionary with the year 1832 with the invention of electromagnetic telegraph. Now, IoT is capable enough of communicating and connecting with a numerous number of devices at a particular time without the intervention of human being. And as stated in the research, it was estimated that around 75 billion devices will be the part of the connected spectrum of IoT by the year 2025. Now, this will be since a huge amount of devices will be connecting in the IoT spectrum of 75 billion devices, that means they will be sending and transmitting the data across the globe, generating a huge amount of data. And that data needs to be secured at any point of time and at any cost, because data is a very valuable asset, including the transactions and operations for any organization. And on the negative side, that means the cyber attacks are also evolving at a particular, at a tremendous pace that tells us that the conventional and the orthodox solutions for IoT are not at all good for the latest security, privacy, and interoperability issues of IoT. That is why there is a requirement for a decentralized peer-to-peer technology that is known as blockchain. So this paper and presentation highlights the importance of solving the diverse issues and challenges of IoT through blockchain and cryptography. Now, we'll see the introductory part as including the applications of IoT, as you can see over here in the screen. The rise of IoT, most of the people think that the rise of IoT started with the 1999 when it was coined by Kevin Ashton and it with the invention of a smart toaster. But the rise of IoT started with many years ago. That means that in 1800s when the long distance communications began, and then with the invention of electromagnetic telegraph, that is in 1832, the rise of IoT became more significant. And then slowly and gradually from the year 1832 to 2025, it has evolved drastically, and by the year 2025, we can get that 75 billion devices will be the part of the connected spectrum of IoT. Then with this tradition, with this issues, with this drastically changing data, and that is generating at every second bit, that means it is generating a huge amount of IoT issues. That means you can see that it is generating incorrect and unauthorized accessing of IoT devices. It has paucity of encryption. It has buggy software vulnerabilities. It has absence of trusted environment for execution. It has minimal privacy of protection, and it has ignorance with intrusion. And to top it all, it has a single point of failure. Now, the corresponding remarks over here that are given by me, that the traditional IoT can easily trust any device that is present in a local network, and it will never go for any kind of authentication as well as authorization. And the traditional IoT also acknowledges that that the IoT follows the vector encryption standards and are vulnerable to many cyber attacks. Additionally, the traditional architecture of IoT always follows the centralized architecture. Additionally, traditional IoT also acknowledges that they, whenever their security is compromised, they function normally. Moving on to the next slide, we have the blockchain. That over here on the screen, we have the block that is acting as a constituent unit of a blockchain. So a block is comprised of two things, that is header and body data. So header comprises of block sequence, previous block hash, current block hash, timestamp, as well as nonce. So nonce is actually a security parameter. That means a number that can be only used once. And these are the characteristics of a structure of a block. Then moving on, that the people basically knows about Bitcoin, that by the year 2008, the first conceptualization of blockchain was released. But this is not so. The original cryptographical blockchain-like protocol was released in 1982 by an American cryptographer, David Combe. And then slowly, and then in 1991, W. Scott Stornett and Stuart Haber released the concept of Merkle root that enhance the security aspect of the blockchain. And then after 17 years after that, that means in 2008, the first conceptualization was released behind the cryptocurrency Bitcoin that involved the usage of the pseudo group that was known as Satoshi Nakamoto. And then moving on, now coming to the aspect of a brute force attack, that means how I'm going to optimize the security attacks, the security of IoT using blockchain and using blockchain and cryptography. So it involves the concept of brute force attack. As you all know, that brute force attack are basically traditional methods that can obtain the sensitive and private information of a user. And what are the different goals of a brute force attack? The different goals of brute force attack are basically redirecting domains to malicious websites, selling sensitive information to untrusted third parties, spreading fake and malicious content, theft of personal information. And then we have hashing. Hashing basically means hashing is acting as a countermeasure to the different cyber attacks that means that involves plain text that is being converted to the hash digest or a message digest by using the different types of secure hashing algorithms. That means SHA-0, SHA-1, SHA-384, SHA-256, SHA-512, and so on. Then we have the digital signature, that is the part of asymmetric key cryptography that basically involves two types of keys. One is known as private key and the second one is known as public key. Since as the name suggests that the private key is private to all and public key is basically public in nature, and with whosoever the encryption algorithm is performed, with the same persons, the other key, the decryption is performed. So this digital signature is a part of asymmetric cryptography that also involves public key cryptography. Now, what is the problem statement? The problem statement is to analyze the efficiency of SHA algorithms for brute force attacks in phase of blockchain and cryptography. Now, since we are dealing with the SHA algorithm, so the SHA, that means we are over here to perform the numerical interpretation of all the SHA algorithms. So if we are having SHA 0 and 1, so the number of bits that it is providing, it is 160, and the possible number of combination it is providing is 2 to the power 160. And we have the hexadecimal digits as 40, and the factorial value will be of 40 factorial. The SHA-0 was released in 1993. That means, and it was released with a flaw. So that means it was taken back very early. So after 2 years, in 1995, it was released by NSA. That means National Security Agency. It released its predecessor, that is SHA-1. Now moving on, if we are considering one possible second for one combination of a brute force attack to tackle, then we have to divide it by 2.628 plus 6, and these are the overall observations that I have found it out. And what are the possible number of months that we can use to decode the possible number of combinations are basically 1.46 into e to the power 41. And then if we will see the possible number of months for decoding the factorial value, then we are obtaining a huge value. That means, as you can see, 3.1046970 e plus 41 months. Now, if this computation is increased 1,000 times, then also the results that are obtained are very huge in number. That means blockchain, this brute force attack is not able to tamper the SHA-0 and SHA-1. So slowly and gradually, if we move on to the next version of SHA, we are having the following characteristic. That means it is having the possible number of combinations that choose about 256, and then we have the number length is 78, and the hexadecimal decimal digits are 64. So it is providing a result, that means, as you can see, if we are considering the decoding of the possible number of combinations, we are getting the value as 4.40 into e to the power e plus 70 months. And if we are trying to decode the factorial value, we are getting the value as 4.82 e plus 82 months. And if we are over here as well, if we are just increasing the factorial speed as well as decoding the possible combinations by 1,000 times, then also you can see that the number becomes, the number over here is such a big number. That means it is impossible to crack at a certain point of time. So as we move on to the last SHA, that we have SHA 512, you can see the possible number of combinations as to the power 512, and we have the number length as 155 and hexadecimal number as 128, and the factorial value is 128 factorial. So if we are doing the same operations over here, we are getting a huge number. That means that is justifying that brute force attack are not able to tamper either SHA 0, 1, 512, and 256. So as you can see, this is the observation that we've obtained over here in the case of SHA 0, 1, 256, and 5 and 2. Apart from that, now moving on to the cryptographical aspect, including SHA, we have the traditional and modern cryptographical algorithms. We have ECC and RSA. ECC stands for elliptic curve cryptography, that was released in 1985 but became more mature in 2005. We have RSA algorithm that was introduced in 1980, that was discovered by 3 scientists, that were Revesh, Shamir, and Adelman. Now, this ECC and RSA are able to provide the same amount of security, but ECC can use very low amount of time, and ECC can use very less amount of keys as well. As you can see over here, that if we are using 160 key size for ECC, then we have to use 1024 key size for RSA, and the security strength that it is providing is 80 bits. And similarly, we have for all this, and you can see that the number of RSA is such a huge, and the ECC size is very small, and then also it is providing the same amount of security. Then in the last, we have the key generation algorithm, key generation time of ECC as well as RSA, that key ECC, RSA, and the key length time and the time. That, as you can see, ECC is far better in comparison to RSA. Why I'm focusing on ECC? Because ECC is a core component of blockchain, and ECC in amalgamation with the digital signature becomes ECDSA, that forms the core component, core security component of blockchain. So here are the blockchain solutions for IoT that have been taken care from the summarized data. We have that blockchain is whatever security issues we've seen in the previous slides that are completely solvable by blockchain, as you can see. And these are the results that I have obtained. That means in SHA 0, 1, 26, and 5 and 2, the brute force attack is not at all feasible. So these are the conclusion, and these are my references. Thank you.
Thank you, Rajas Verma, sir.
Yes, sir.
Any question to participant side? No question. Okay, proceed, sir. Over to proceed, sir.
Any questions from anyone? Is there any questions from audience?
No question, sir. I see that.
I think the session is over now.
Sir, any question towards your side?
No question.
Okay. Yes. So thank you very much, sir. Thank you a lot of time you have given between us, sir. And I hope all research scholar and faculty who have present here will be definitely benefited by your nice suggestion in the field of mathematical modeling. Thank you very much, sir. And all participants, thank you very much. Over to Manoj, sir, further proceeding.
Thank you, Rajan, sir.
Thank you very much, sir.
In the end, I would like to thank Professor Ram Naresh, sir, for finding the valuable time from his very busy schedule. Also, I would like to thank Rajan, sir, for conducting the session. And in the end, I would like to thank all the participants participated in the session. Thank you all once again.
Thank you very much, sir. Thank you.
Thank you, everybody. Thank you so much.
Okay. Thank you. Thank you very much. Pranam, sir.
Pranam.
Participate, we can leave the meeting.